Kann ich anfangen? Wunderbar. All right, awesome. Yeah. We should still be able to project my screen. That would be great. Exactly. Test. Well, the laptop thinks it's doing its thing. Perfect. F5. Wait, what? Das ist nicht so der Tag. Because we were only allowed 5 words. A bit more realistic of a title would be How Two Math Workers Won a Geoscience Hackathon with Deep Learning, and of course they used MATLAB because they work at the MathWorks. So deep learning nowadays, it's a technology that's impacting all our customers, and I say it's also impacting people here at this hackathon. So customers from aerospace, automotive, industrial machinery, semiconductors, trains, neuroscience, medical devices, all of these fields, deep learning is playing more and more of a role nowadays. I have brought 4 examples to kind of visualize this a bit. So on the top left, we have an example from Airbus. They're doing automatic defect detection using object detector networks, using deep learning to inspect parts of the airplanes. Top right is from a company who does industrial cutters. They do anomaly detection, predictive maintenance using variational autoencoders, so pretty powerful technology actually for this kind of task. Bottom left, medical imaging. I think we're all aware that this is a very strong field where deep learning plays a very important role to detect tumors, to detect cells, to segment complex images. And bottom right, that's from railways to detect cracks on the railway tracks. So if anyone from Siemens is here, that's something to pick up. Yeah, I think that goes to show deep learning has made the leap from research to actual industrial applications, and more of these are emerging. But today I'm here to talk a bit about how my colleagues won this geoscience hackathon. And I guess the first question when you have a hackathon is, what is actually the challenge? So the challenge here was that on the left, we have a visualization of echo traces of geoscience data. So this is kind of going down into ground and getting an echo of the different layers of the ground. And the goal was to automatically label these segments, and all these colors represent different types of rock, different types of inclusions in the ground. So essentially, there's going to be 3 steps. What we actually have are these echo traces. So essentially, they had a device, they put it down, and they measured down into the ground, they got an echo trace back up, and they moved 10 meters to the left. Again, they got another echo trace, and they did this for a pretty large grid. And in the end, you can visualize it as this kind of 2D image if you want. So we're going to do some pre-processing on the echo traces. Then we're going to train some recurrent networks to try and automatically label these different kinds of rock. And then hopefully we'll get this right. So yeah, actually, I don't want to have too many slides because it is a hackathon, so I don't need to do too much marketing. I'll just want to actually go a bit through MATLAB with you together. And let's look at what we've done. So yeah, we can see MATLAB, that's great. So the first thing we did, we had to actually explore the data set, look a bit at what's happening. So we loaded that in, and it's a 3D volume. So what we can actually do, funny enough, I figured it out after a while, there's a volume viewer app. So we don't have to visualize this ourselves, we can just load our volume in here. So if you load these echo traces in and visualize it as a grayscale image, well, it's not so easy to see, right, what exactly is happening. I guess my main takeaway is that labeling this manually would be quite the nightmare. Apparently it's possible. Experts can do it. They can see where one strata of rock starts and another layer of rock ends. But for me, as a layperson, this is kind of impossible. But we can also visualize the labeled volume of rock. It looks a bit like this. And okay, I guess here we can see there is some structure. So one thing that's important to note, again, you should understand the challenge, right? Actually, this top and bottom layer of rock, they're not that important. Like the geoscience people, they know that these layers are there, they don't care. What they care about is these kind of smaller, the bluish one, for example, which is more rare, or this red one. So these are weighted much higher in the final score. So the task is to develop an algorithm that does a very good job, especially on these more rare layers. And if you get the yellow one right as well, you don't score that high. So what's been the traditional approach? Traditionally, what people have done in the field is they took the left image, they trained the semantic segmentation network to try and pixel label this in order to get the labeled image on the right. This works well on the training data. Funny enough, it tends to really overfit a lot, and it tends then to miss on test data. It tends to miss the actual rarer classes, which are the ones we are interested in. So approaches were not that great. However, since what we have is not an image, what we have are these echo traces, we thought, why don't we train recurrent neural networks on these traces and try to do a signal-based approach? So let's see what we did. So yeah, we're going to go a bit through this, this script here and check all the things. So again, I loaded in the data. It's about 1.5 gigabytes. So it's a 3D matrix, 1.5 gigabytes. And to get started, I want to iterate a bit faster. So it's too much data for me, 1.5 gigabytes. Also, my laptop is poor and old, and it tends to, tends to not do so well. So I downsampled the data. So if you look from the top down on our volume, I took only every 10th point in the X and Y direction. So all the red dots, that's the traces I took. So I reduced the size of my data by a factor of 100, while still covering the whole training data to make sure I don't miss anything. And this worked out quite well. Now my training data was much smaller than before, and it took me 2 lines to downsample that, of course. I reshaped it a bit to make sure I get it into the size so I can feed it into my neural network, and then I used 90% of it as training data, 10% as validation data, just to make sure we can also kind of validate what we do. So now I started out with training a GRU classifier, and let me just pop up this thingy. So what I did, I used the Deep Network Designer. It's quite a convenient tool to create neural networks. So we can get a sequence input layer, right? So input size is 1 because each signal trace has 1 signal in it. And then I kind of dragged in some GRU layers. And I think I took 2 of them. And well, in the end, we need some classification layer, and we need an activation layer somewhere as well, I guess. Let's see, something like this. Now the cool thing is I can just drag and drop this. I have 6 classes, in fact. I can auto-range this, and now I can analyze if what I made is correct. So that's also pretty convenient. Now this is a small network, and some of you might already have spotted what I've been doing wrong. Because actually a class output layer needs a softmax layer in front of it. I think what's really nice about this interface is here that it can tell me what I did wrong. So if any of the dimensions would be mismatched, or if I kind of connected stuff together that doesn't work, then it's just gonna give me an error, and I can put this back, and I can reanalyze it. And this is how I kind of assembled this pretty simple network. And then to actually train it programmatically, I just generated some MATLAB code from that, which takes a second. So that ended up with this thing. So I didn't need to go into the doc to look up what all the layers are and what they're named and stuff. I could just copy paste this output from my app. And that's kind of what we came up with here. I added some layer normalizations as well to keep everything nice, to keep the gradients nice. And yeah, then I trained that. I trained that for 15 epochs. It's not too long, not too short. I played a bit with the mini batch size, initial learning rate, and then ended up with a plot which, well, we see on the top the accuracy. Accuracy goes up, that's usually good. And on the bottom we see the loss function. We're trying to minimize that, that goes down. So that's a very good first sign because at least in principle I'm doing things right. So it's learning something. And we ended up with an accuracy of 87%. That sounds pretty decent. However, if we take a bit of a closer look, it paints less of a rosy picture. Because, well, we see especially class number 3 and number 5, they're classified as class number 2. And if we look at the challenge again, classes number 3 and 5 are the ones that are important for the challenge. So if we misclassify those, we'll just get a very poor score in the end and it will not do well at all. So one thing we also figured out when you look a bit more closely is that classes 3 and 5 are much rarer. So the data set is quite imbalanced and they're not that common. So I guess the next kind of obvious thing to do if you have a rare class is you could introduce class weights to penalize the network harder for misclassifying the rare classes. So I computed a bit what is kind of the percentage of the different classes in my training data. And if we look more closely, we can see it's 1% of the training data is actually class 5, while 40% is class 2. So yeah, we can kind of see why the network kind of ignores these rare classes. So I copy-pasted from above my network, and I added my class weights, and I just retrained that with exactly the same code and parameters from above. And again, we see, well, actually the accuracy is now a bit lower. Before I had 87, now we had 76. So at the first glance, we might say, well, it's worse now than before. But if we look at the confusion matrix, all right, class 2 is now not covered so well, but all the others are done much better. So are we doing worse or better than before? Kind of depends on your criteria, right? I mean, it's not bad, and I could play a bit more now with my class weights, trying to get class 2 a bit up again. But I think now I thought, well, maybe try some other approaches. For example, we could change our network structure. Instead of using a GRU layer for a recurrent network, we could try a bi-LSTM layer. So a GRU layer takes a sequence only from beginning to the end, while a bi-LSTM layer can use information from both sides to classify a certain point. So it should be more powerful, because it can kind of access more information. And yeah, I changed that. I just changed my GRU layers to bi-LSTM layers, and I kept everything else, again, the same. And again, the same training loop. And now we reached 80%, which sounds quite a bit better than before. And also, if we look here, we gained about 10% here on class number 2, and all the others also went up a little bit. So this approach, okay, it seems to work. And now we could try more. We could play a bit with my network, maybe make it bigger, maybe add other layers. But I think there's maybe a more powerful approach we could do. We could go back to feature engineering. Because so far we just feed in one single trace, and that's fine, but maybe there's more information to be gained if we help the network out a bit by first doing feature engineering. And what we did here, I mean, again, I took my data and I used wavelet transformations to kind of decompose my waveforms into this multi-resolution signal. So we can use wavelets to decompose an oscillatory signal into this more powerful representation. So I don't want to go into the details of it. It's not actually that trivial. But the cool thing is, again, with the app here, I could do this really easily, generate the code to generate all of this myself. And it provides the network with more information to learn. So now it has not only one signal, it has actually 5 features for each point. And to improve it a bit more, I thought, why should I take only one trace? I could also take the neighboring traces, because I kind of assume if I want to label a certain point, it's not going to be only here. All the surrounding points should have the same label. So I should be able to take information and signals from the surrounding ones as well to get more information, smooth out any noise, kind of improve things. So instead of taking only one trace, we took a 3x3 piece, and we took all of these to classify the middle one. So speaking about the data, we ended up with, instead of 1, we end up with 3x3x5, 45 features, instead of only 1 feature for each trace. And yeah, here's some code to just do this. It's a pretty simple function, actually, to do this wavelet decomposition. And I actually saved this for later use, because it takes quite a while to run. And now, yeah, I'm using this new data. So I load in my new data with the MRA features. I actually keep the same network structure as before, so I keep my LSTM network, but it gave me better results, so I think it's a good approach. I just needed to change the input size, so instead of 1 signal, we now have 45 features, so that's the only change from before. Now, it's not the only change, I actually also changed a bit the hidden units, so I increased the power of my network, I gave it more parameters, because if it has more features, it should have a bit more representative power as well. And now I trained it. I actually trained it now a bit longer for 100 epochs. I also decreased the learning rate a bit because it was spiking more than before. And now we see we got 96% accuracy. So that's up from 80 before. And also, if we look at the confusion matrix now, we end up with, I think, yeah, all of these accuracies are now above 90%. Which is pretty impressive, considering that before we had, what, 60% on class number 2. So I think this looks pretty good. And to kind of confirm my intuition a bit more, we can also just visualize it. And now we see, when you open this up. So I just visualized one slice of the plane going down. On the left, so in the middle, we see the ground truth, and on the right, we see the predicted labels of our network, and I guess we can agree that it's doing a pretty good job. We can see that there's some kind of noise at the edges. It's kind of jittery. That's because we're doing each prediction trace by trace, so the neighboring traces don't know. They don't kind of communicate, so of course, there will be some noise in the fringes. There might be other neural networks we could now try, which maybe predict for patches or for areas to kind of try and improve this a bit. We could post-process it. We could use some image processing to smoothen the edges if it's actually necessary. Or maybe also the people who use the results will just say, this is easily good enough. For me, I don't need any more accurate information. But yeah, and this was more or less the final state. And compared to approaches which relied on semantic segmentation, which the other teams used, the MathWorks team with the signal-based approach, I think they got about twice as good of an accuracy in the end, so weighted accuracy. So it's quite an impressive change, a step up from the other approaches. Yeah, and that's about it. Actually, one thing I wanted to also mention, and now we don't see it anymore. Let me just try this. Right. One thing I actually wanted to say as well, I didn't train all of this on my laptop because I started out and realized it's actually a bit old and slow and runs out of memory. So I actually did on AWS. So I got one of these AWS instances. It's quite easy to set up. You can get on GitHub reference architecture. You follow the 10 steps, and then within 10 minutes, you're up and running. So that's quite convenient. And then you can just SSH in or RDP in and run stuff there. Sorry, I keep it up for the picture. Yeah, so I want to quickly summarize everything I did by looking at the deep learning workflow. So the first thing was data preparation. So we visualized the data we had, used this volume viewer app in our case, and we used this multi-resolution analyzer to extract more features from our signal to get a more powerful prediction. We did some AI modeling, the second step. So we trained networks, we built networks with the Deep Network Designer. We simulated and tested stuff, so no simulation, but tests. So we had the validation, we looked at this classification matrix, we looked at the visual output, and actually then, of course, in the end, the hackathon organizers also gave the test scores. What I didn't talk about right now is deployment, because it did not matter, it did not factor in this challenge, but of course it's a very important step. And one other thing I quickly want to mention, that's another tool I could have used, and in the hindsight I probably should have used, it's the experiment manager. Because we trained a bunch of networks, we tried a bunch of hyperparameters, I tried a bunch of networks, and if you use the experiment manager, it's a small interface, it's a small app again, which kind of makes it easier to organize stuff. You can compare results, you can keep track of all your experiments, you don't need to write all the lines of code I did to then compare it afterwards. And you can even optimally explore hyperparameters, Bayesian hyperparameter optimization to get even better results. So that's a pretty cool app I could have used. Also something I want to mention, if you're using more advanced networks, like transformers, GANs, autoencoders, there's now a public GitHub repo from our developers, because it usually takes a bunch of releases for things to transition into the official documentation. But of course, deep learning is a field where things happen fast. So you can go on GitHub, you can check, there's a lot of cool examples with very cutting edge networks, which you can just download and use for free. Now I want to lose a few words about deployment. So in the end, the network usually needs to go somewhere, do its job. And from MATLAB, there's two routes to deployment. You can either generate software components, so you can create C++ DLLs, Python packages, you can make web apps, you can deploy things on production server to actually have proper enterprise integration. Or you can go the other route, on the left-hand side, you can automatically generate code, which is then real C, C++ code for embedded devices, CUDA code for GPUs, PLC, or even HDL codes for FPGAs. That's especially relevant nowadays in aerospace. And translate your network, bring it from MATLAB to an embedded real-time device. So that's a very powerful capability, I think, and is becoming more and more relevant now that deep learning is transitioning into the real world. So I think deep learning has undergone a very rapid evolution, and that's also reflected in the capabilities of deep learning in MATLAB, I guess. So 2016, we had CNNs, normal convolutional networks. And since then, there's been a lot of effort spent on getting up to speed, really diving into this technology, hiring a lot of new developers to bring stuff for normal deep learning, reinforcement learning, graph neural networks, all the fancy stuff. And I think that brings me to the end. So MathWorks, that's us, founded in 1984 in the US, main tools MATLAB and Simulink, you might know us. And now over 5,000 people, still going strong. We have an office in Bern in Switzerland. That's where I am with my two colleagues who are now here as well. And feel free to come and chat to us. We're here until 5, 6-ish today. And we're working on the Siemens Challenge, which is great fun too. So if you want to talk about that, we're also happy to do that. Thanks. And if you have any questions or want to email me, then feel free.
Good morning, everybody. Thanks for being here. I know you probably got just a few moments of sleep during the last night and are super busy with hacking. So we're really happy to be here today and show you something that is hopefully also interesting to you, and will provide you with some ideas of what we are doing and actually how to be successful with hackathons and Microsoft and GitHub tools to the extent possible. So what we will do today is my colleague Michele and I will walk you through some developer tooling that we think is totally amazing. It's recently released in GA. It's called GitHub Code Spaces, and it really focuses on getting your developer environment in the cloud up and running fast, which is actually a good thing, especially when you don't have a lot of time and you don't want to spend days on configuring and setting up your environment for development. Before that, we will start with, let's say, something that is commonly asked by participants trying to use Azure and our cloud services. So Michele will walk us through how to get started with an Azure Pass, then how to deploy some example project, and then how to develop with GitHub Code Spaces. And we would love to hear the feedback from you, what you think about it, and maybe you used it already and you have some specific questions. So yeah, really looking forward to the discussion with you. And with that, I would like to hand over to Michele.
So good morning also from my side. Regarding the questions, our booth is on the entry on the left side, so reach out anytime you have any questions. I have no idea who is in here in the room, but yeah, it's blending a lot. So, but yeah, let's get started. So, if you think that you might gonna need a platform where you're gonna run your applications or whatever you're gonna build, so if it's based on software, more or less, you can join us and come and request a so-called Azure voucher, an Azure Pass. The intention is to give you for 30 days $100 available to you to build whatever you need to build or whatever your intent is to build to accomplish one or even multiple challenges, depending on how long you don't want to sleep over these 40 next hours. And to do so, you can reach out to us via the Slack channel, reach out by sharing your team name, and we will reply by giving you a voucher. And the next logical step is actually to hit this URL called microsoftazurepass.com, where you just need to log in with a Microsoft account, which practically means something like an at Outlook or at Hotmail or something address. You log in, you enter your voucher, and you're good to go. And I've done that yesterday, just to speed up time. That's where you enter the voucher, and then you're good to go. And the next thing where you will land is on what we call the Azure portal. And as you imagine, the URL is portal.azure.com, and the intention is to give you a so-called subscription, which in Microsoft terms is just a billing container. Nothing to do with the Docker container, but just a billing account for you, again, for 100 days, for 90 days, $100 to build everything you want. So I have here one already created. It's called Azure Pass Sponsorship. It's going to last for the next 90 days to build something on top of it. One common question, as Florian was mentioning, is that usually you as a team are usually not a one-man show or a one-woman show. So if you want to invite your colleagues to also build or leverage that Azure platform, the moment you hit the Azure portal, let me actually go back, you will find those subscriptions, and within those subscriptions you will find, if you have already actually attended earlier hackathons and you were already using Azure, you will find that you will have more than one, because potentially, yes, last year you were already using one. So you hit the one from this year, and here you have the access control. So that was like the most common question of yesterday. And then you can assign to someone the same access, saying, hey, I want to give to Florian, owner in Microsoft terms is actually the admin. I'll enter his email address, which I don't know, but yesterday a very nice lady was joining me asking, hey, how does that work? So I'll add her as an admin, with a very high resolution of that screen. Good to go. And behind the scenes now, she will also get access to the Azure subscription and can build amazing things on top of it. What we haven't developed yet is a service that builds your hackathon project, but we will look at it next year so that you can just click and build me the hackathon project. But for now, the second amazing thing in Azure is that if we go back to the portal, we have the so-called DevOps starter. So at least from my subjective or personal perspective, even during a hackathon, a good practice should be to store your code and potentially even the platform that you're running your code, everything as code, so that you can have something to collaborate with, practically a Git repository. And Microsoft has these so-called DevOps starters, which are a set of a demo application based on different technologies and based on different platforms. So if you want to run a simple website, we have some technology for running websites. If you want to run tons of microservices based on Kubernetes, we have a sample application for that. And what you will get out of it, I mean, let me walk you through an example here. What you will get out of it is then a fully application as code approach on GitHub and also the infrastructure as code on GitHub, so that you can scale and build both during the next few days. Actually, that session should have happened yesterday evening when you were starting coding, but in case you haven't started yet, you're still in time to do so. I've also learned from Florian that Python seems to be a very common technology, or language at least, that it's going to be used here during those 2 or 3 days. So we have samples for different, or the most common, let's say, languages and technologies. Me, myself, I would feel only comfortable in the .NET world. But in case you want to have a start with Python, let's choose that. We can choose the language. We can just have a simple Python application, and to be honest, to not fail here on stage, I will try to stick to the simple Python application. But in case you want to have other, like, I don't know, web framework-based Python frameworks like Bottle, never heard about it, but if that's what you're looking for, you choose your stack, Python-based stack. You choose where you want to run that, right? So if I'm going shortly back and take a web-based framework for Python, I could run it as a web application, for example, because it's a web-based framework, right? Now, mine here, the simple web app, I would like to run it as an Azure function. So it's an event-driven thing. It's like having just one simple API, or you can build also more, to just say, hey, I need some logic that does something and reports back the result. So that's it, actually. You have now a sample application. You will have the full infrastructure built up.
Just to add on that a little bit, just mind you, this is not the only way to do this. Basically, these DevOps starters are helping you get started and set up things quickly. You can also, of course, manually set it up by yourself, not using Azure DevOps or something. You can also use it with, even with other platforms. I don't know why anybody would want to do that, but it's possible. So basically, these starter templates are just to get you started and get the demo application ready fast in Azure.
Absolutely. Yeah. And given that we are here also representing the GitHub team, I've chosen actually to build that application on GitHub so that I can show you later how GitHub code spaces could be something that supports your hackathon hours here. So therefore, I need to authenticate myself towards my GitHub account, which I did already yesterday. So it's important to also have a GitHub account if you want to store your common code somewhere. So I have one here. That's my GitHub handle, and then I would like to start a new project there or a new repository. So let's call it HackZurich, I don't know, demo 42, whatever. As you may see, I have an Azure Pass sponsorship. That's my subscription I'm going to leverage or to build stuff on, and that's actually it. And since we are in Europe, here's, I assume at least, here, let's choose Europe, where everything is going to be installed in Azure or run in Azure. Great. And soon, whatever soon means, the application will be provisioned.
I like your trust doing like real life demos here.
Yeah,
right?
it's
nothing scripted and prepared.
That's true. Let's see whether we can stick to the time. So what will happen behind the scenes? Behind the scenes, now this automation or this baseline demonstration sort of thing will go and create for me on GitHub a new repository. It will actually pre-fill the repository with a sample application and with a sample infrastructure. So I'm not going to build anything manually. It's all based on code. It's like everything as code, an everything as code approach. That allows me then to extend the application really by having Git-specific practices, and also to extend the infrastructure. So if I need more APIs, I can code all that, or someone else can actually look at the platform aspect, whereas another part of the team is looking at the application sort of aspect. Quite slow today, but soon it's going to land. So I should now be able, now here I'm back on my GitHub side. And I should now be able to see here, if I browse the repositories that I have belong to me, oh, it's already here. So I have the repository up and running. It's a very simple Python application. It just tells you back, hi, whatever your name is. And but what is interesting about this demo project, or these so-called DevOps starters, from a learning experience, right? You have an application that you can use as a baseline, or you can throw everything away and build your own application. But you also have the infrastructure aspect. So you don't need to go and learn a lot of things in Azure just to get started. It has already something that you can start using. So in this case, an Azure function, which is the platform where your API is running, it's already built behind the scenes.
Yeah, and maybe for those of you who don't use Azure regularly, ARM templates, ARM means Azure Resource Manager, which is actually the only way, or the way to tell Azure what to deploy, or what resources you want to have. So this is the templating language of Azure. You can also use other technologies. Of course, you could use Terraform or Bicep or something like that. But this is just part of the starter templates, of course. So you can just get started with it, or change this to whatever technology you want to use.
And as you may imagine, if you're already using GitHub, we want to also to leverage the native tools of GitHub, which is their CI/CD, the continuous integration and continuous deployment pipeline, which in GitHub naming convention is called GitHub Actions. So what this actually is just a workflow file that actually instruct GitHub on how to build the infrastructure first, and then the application that I need on top of it, or vice versa. So here I'm building a Python application first. I mean, it's just Python, right? So you get all your Python installables, or everything that you need to import, and then you test your application, and that's it. And then you deploy your Azure function. You do the infrastructure as code aspect, or it's actually doing it behind the scenes. When this CI/CD is done, that allows you actually to continuously having that versioned approach of building on top of it. So that's the whole purpose of actually using a Git-based solution and a CI/CD pipeline.
Maybe a quick question. Who of you are using GitHub Actions today already? Oh, yeah.
One, two,
at least
three.
That's at least 80%.
Yeah, so
a few at least, right? So
one of the many.
GitHub Actions, just for those who are not aware, is our, let's say, automation language for CI/CD on GitHub natively, and it's basically versioned YAML file where you describe what should be deployed, the different deployment steps, and what you can do there, especially is what probably some people call GitOps these days, I guess.
True.
So you basically control the workflow and the build and the integration of your application using Git workflows, like pushing to the repository, open pull requests, merging pull requests. This will trigger the builds. This can also work with different environments, like that the pull requests stand up, let's say, a staging environment first, and when you merge a pull request, it updates production environment. So this is basically the GitHub technology for doing all these kind of things. And with the starter template, again, you get a pre-created, let's say, sample or working sample file of this GitHub workflow.
Exactly.
And then afterwards, it's your own. You can modify it, you can change it, and make your build do whatever you want to do with it.
So talking about modification now is actually the last part, but the most amazing, in my opinion, part is while my CI/CD pipeline is now doing something, now teams should actually start and code something, change something, whatever. So you either set up your full notebook, which is that device here full of stickers. If you're looking for stickers, just join us. Or, and this is where Code Spaces comes in, you have here the ability on GitHub to go and either use your preferred development environment, be that Visual Studio Code or IntelliJ or whatever, or something new, which is called GitHub Codespaces, which is a web-based technology that does give you the ability to actually have a full IDE experience based on browser technology, so HTTP sort of experience. So if I'm hitting here and creating my new GitHub Codespace, behind the scenes, it is actually just using container technology, so it's just a Docker container that contains my full development environment. The cool thing is that I don't need any installed application, nothing on my local machine, so I can start code from wherever I am, whichever device gets actually handed over to me. It's all online. You can then actually combine it with other IDEs, but if you just need to get started, here I am.
I mean, and that's kind of beautiful. In case you didn't notice, this is Visual Studio Code in the browser because it's built on Electron, so it can run in the browser. But again, if you have trust issues with running your IDE in a browser, we tried it a few times in the past. For some reason, developers don't love it that much. Of course, you can work with your local installation of Visual Studio Code and then connect to that Codespaces container from a desktop application.
Yeah. So, as you may imagine, usual IDE, you choose whatever nice theme that you would like to have. I can only recommend from a theme perspective to use the Dracula theme, which is nothing to do with the talk, but it's an amazing theme that you need to look at. It's called Dracula. They have the best colors for each and every IDE. So the moment you install that, just the IDE experience, the color are going to be amazing.
All right.
That's totally important. That's totally important.
Of course.
So going back here, what I have now here is the full Visual Studio experience, Visual Studio Code experience, to be honest. And now I'm able actually to start coding. So which means that here I have again my GitHub repository with my Python application, very smart Python application that takes an input, an HTTP GET input, a query input, and just replies by saying hello.
Maybe a quick question. Anybody uses Azure Functions or knows this kind of code we are just showing? All right.
One.
And again,
become less
80%. Yeah, a few people at least. So this is our serverless compute service on Azure, Azure Functions. So it's basically you don't need to run any container or web server or something like that. Yeah.
Cool. So last thing here is that someone was challenging us this morning, saying, "Hey, why the heck are you wearing a Linux T-shirt? You're from Microsoft, right?" But the idea here is that there is so much Linux technology nowadays in Microsoft, and just to give an idea here, just to run my application, I would need here to run my Azure Functions core tool. So it's practically a lightweight backend server that serves then my web application. So to do so, I assume the one of you who are actually into Linux, they would recognize that these sort of commands are actually not so much Windows-based commands, right? So I'm actually updating my Unix-based container here that is running my Visual Studio and will soon run Microsoft technology, in this case an Azure function. And I also need to install the Azure function sudo apt-get install. I think it's Azure
I think you have a typo.
Functions core tools 3. Do I have a typo somewhere? Sudom? No, that sounds like, I don't know, different language.
It's like Sodom and Gomorrah with you.
Yeah, right? Potentially. So here we go, installing whatever we need. By the way, Codespaces has a cool functionality where you can actually predefine or define what preconditions my Codespaces environment need to have. So if you're a Java developer and need to have everything Maven specific set up upfront, you can define all those setups in a precondition file. It's called def container, and every time you start your Codespace environment, that's all gonna be already executed for you, so that you really just hitting Codespaces and you're up and running. The same goes for Node, or for if you want to pre-install all the NPM packages, you can have that action as an upfront condition. So the moment the Codespaces is up and running, you're good to go without needing to have 10 gigabyte of internet connection first to download all these NPM packages. Or like here, to get that stuff up and running.
Yeah.
But soon, we can shortly close the demo by showing you that with CodeSpaces, we can now start coding whatever we want to, and never having actually left the browser, which in this hackathon experience could actually save you so much time to not have to spend hours in setting up your environment, just to be able to give it a run. So here, as Florian was suggesting, my environment here is an Azure function, so the moment I get starting it, actually, I need to have the function first, right? So here we go. The cool thing about CodeSpaces also, just another cool thing, there are so many cool things, is that, as you may imagine, so I'm running here my function in a container somewhere remotely. I don't care where it is. So, but it says localhost, but localhost of that remote container. So it's somewhere in the world, I have no idea. But CodeSpaces is smart. So whenever I'm gonna now hit that link, it has a reverse proxy integrated in it, giving me the chance to actually use that reverse proxy again from a browser perspective and testing my API functionalities. So if I am going here saying, no, that's just a sample application, so I'm giving it a name like, as you may imagine, HackZurich is something good. So it should actually report back saying, hello, HackZurich. So as you can see from the URL, I'm actually remoting with a reverse proxy in that thing, never having touched, never having built an environment, just there. And I can start just coding out of the box. Mm-hmm. Ta-da! That's it.
So that's wonderful, and as Michele also mentioned, there's a lot more that you can do. So basically what should happen right now, if you have any repository on GitHub, you, like having Node code or Python or something like that, you hit the dot key, and it should launch this default dev container. As you said, you can configure what kind of development environment you want to have with the dev container JSON file, or is it YAML? I don't remember, but with the dev container file to customize the environments that that your code space is launched in. But other than that, it will just launch in a default development container, which works for many of the common technologies like NPM, or is installed, or I think the basic Python tools. And the good thing is there's a free tier, so you can, I think with public repositories, you can try it with, right now. And yeah, we would love to hear your feedback. We would love to hear what you think about it. Is it useful? Because we have discussions, of course. Some people say, well, I don't want to have my developer container in the cloud. Or I said, like, no, I want every developer in our organization to have their own handcrafted local IDE setup or something like that. If you have any opinion on that, come to our booth or challenge us on Slack, and we are happy to discuss what you would like to see.
Or do both, yeah, absolutely.
Yeah, all right. So maybe quickly into the audience here. I really don't see that well with the lights, but yeah, any questions? Oh yeah, somebody's waving. So the question was if the container is now running on Azure or on GitHub. Actually,
it's running on Azure from GitHub.
Yes. So, of course, GitHub is running on Azure meanwhile, which may have to do with the fact that Microsoft acquired GitHub a while back. But yeah, so basically it is a container that gets spun up on let's say, the Azure cloud, but within it's part of GitHub.
So
right?
it's very intransparent. It's just a GitHub service that you will get, so that whenever you're logging in GitHub and using your GitHub profile and your GitHub account, you have this new capability called CodeSpaces, and it's just a GitHub service. Now, behind the scenes, they are using different data centers and different cloud providers, and one of it is Azure, but it's not directly tied to your Azure subscription, the sponsorship that you will get here. It's just coincidentally the same technology behind the scenes.
Yeah.
I hope that helps. So would it be possible to connect this Azure subscription with the CodeSpaces? Yeah, absolutely, it is. So when you are here on Code Spaces, so it is a Visual Studio Code experience. So if I'm going to hit here and say, give me some Azure function capability, just to show you here, I'm going to install the Azure function extension in my code space, in my Visual Studio Code. This will allow me here to link back, as soon as this extension is installed. Here we go. Source group. Just a second. Here, Azure account. I should see. It will hopefully soon load. Nevertheless, you can, as soon as it's going to load here, you will be able to actually link the code spaces to your Azure subscription. So whatever you're going to build now in your subscription can also be deployed from here. So I will, from here, also see that Azure function that I've just deployed via GitHub here somewhere. So that Azure function will be actually also visible from my code space. So you can build as many services as you want, also outside, and you will be then able to.
Yeah. It's just like your normal development environment. You can install the Azure tools, you can log into Azure, and you can work with all the other services in your subscription, in your Azure account. And if the question was more about if that function that I built there can communicate with other, I don't know, VMs or other services
Absolutely,
on Azure. Yeah, I mean, this is just a normal Azure application. So you do whatever you do there, like put them in the same VNet or make them communicate with each other. So
that's correct.
There's nothing special about the services you develop.
Exactly. So this is just a very normal Azure function here, where you would be able now here to. I don't know why this is so.
I think we're over time, so maybe if you have more questions, come to our booth.
Yeah, exactly.
And
join us, and we will answer all your questions. Or
you will answer all the questions.
All
right.
I will answer.
Thanks a lot, and have fun with HackZurich.
gonna tell you today how you can actually get your visions really going. And I will show you how to create your digital innovation roadmap. This is very helpful if you have big ideas and you don't know how to slice them down and make them possible. So maybe quickly about me, who I am, where I'm coming from. At the moment I work as a head of corporate development, IT and innovation in Andermatt Swiss Alps. I tell you a little bit more what the Swiss Alps Andermatt is actually doing. Before I was running the F10 incubator in Zurich, I was also the head of innovation for Paymeet, which then was merged to Twint, so I know about digital ecosystem, how you can get them really on. I also are a lecturer about innovation management here in Zurich, and I'm also destroyed a startup so far. So let me talk about Andermatt Swiss Alps first, who we are. So what we basically do, we build very nice real estates up in Andermatt. They look like this, or like this, or like this. So if you are very successful ones with your startup, this could be yours, or this could be yours. We also operate and build hotels in Andermatt. We have also a cable car, which makes it quite interesting from a developer point of view, because we have 152 touch points, and of course we have about as many systems behind, because we also operate, for example, the golf court. We have about 15 restaurants, and we are a part of the Orascom development, which does the same in 8 other countries or 14 destinations all over Europe, and especially North Africa and a little bit in Oman. So if you question yourself, dude, why are you at the hackathon? You're totally right. I explain you quickly. So what we actually started up in Andermatt is actually our founder, Sami Saviris, 15 years ago, he bought 1.5 million of square meter of land from the Swiss Army, because it was army land. It looked like this, and what actually is very nice about it, we have like greenfield, really greenfield, and have now the duty to build up the future of Andermatt and developing a town. So if you ask yourself, shall I build an app or shall I build a town? Probably building a town is more exciting. So what we're doing actually, we're trying to make sure that actually skiing is fun. We make sure that actually the town further grows. We have a chalet, which we are building in the future. We are, as said, running different kind of things. But this is probably boring for you. So let's talk a little bit, why am I here and why do I need help of startups and hackers? And why do we have an open API since yesterday? Our vision is actually we want to be the prime Alpine destination, meaning we want really to be different than other Alpine destinations. And therefore my team has like the vision and the mission to make sure we enable a whole organization of hotels, restaurants, etc., to really be able to provide an outstanding customer experience to our clients. So, and if you think of, and this is now actually the learning part, if you want to do something amazing or very sophisticated and very visionary, it's important that you do 4 things. You first need to understand the trends. I'm talking about micro trends, I'm talking about macro trends, but I'm also talking about mega trends. And if you don't understand them, it's probably you're going in the wrong direction. So you have to understand your trends. And of course, since you are at the hackathon, you also have to understand your technologies, because they will be the big change of the future. You know, they drive the change. And very important also, do not forget about the customer. Your customers need to understand what you need to understand them, because you need to understand what kind of lifestyle they have, and you need to understand what they are really looking for. And understand you are never alone in the market. Then you also have to look at your competitors. What are best practices? Because your customer expect those best practices in little. And since we in Andermatt, we want to be the prime Alpine destination, meaning we want to do something very, very magical. For us, actually, it's pretty challenging, because, you know, if you look at the offering structure, you normally start with a basic, you know, this is what your customers expected, or this is not really adding value because it's a commodity. I mean, very easy example, some years ago, you were very innovative as a car manufacturer if you had an AC, an air condition, but once everybody had an air condition, it actually got a commodity and people were expecting, otherwise they will not buy your car. And if you want to be really magical and prime, you have to be better than everybody else, and you have to create individual experience. And the problem is in the global world that you constantly competing against other destinations all over the globe. Or for example, one of our hotels, the Jetty, is one of the best 5-star hotels in the world. Our guests, they travel all over the world and they see everything and can use everything at their fingertips. So somehow we have to be better than others. So what is our approach and why are we here? We actually created the picture of the future of Andermatt 2040 and looked at, hey, based on future trends, how will Andermatt develop? And for example, one question we had to ask, well, we are on 1,400 meters above sea level. Will there still be snow? So does it make sense to build another cable car? Because maybe there are no skiers anymore. Or on the other hand, we also found out, well, 27% of people living in the world or in Europe by 2040 will be above 65. And they normally don't ski. So maybe we should build a retirement home or something which is very good for healthy people. Well, so what we came up is actually with 6 different theses how we want to develop Andermatt. And the great thing about it is now actually, since we have this great field, we can really do this leapfrogging and can actually build the future as we have created. And here is how we did it, or here is actually how we plan to do it and how we can be part of it. So we slice down actually, hey, what are the innovation fields we must understand in the future? And one of them is, for example, mobility. Did you guys know that by probably next year or the year after, flying taxis, drone taxis, will be allowed to fly in Europe? So this means those taxi drivers like Lilium or Volocopter, they are talking about that they will bring you from A to B for a price of a taxis in 1 hour up to 300 kilometers. So this means for Andermatt is sooner or later actually your first place where you can live and work in Zurich. So I mean, this changes totally. So therefore, we even as a small town or a small operator in the towns, we must understand how this trend develops. Because remember, we want to be the prime Alpen destination. So our guests expect actually to maybe fly with the drone taxis in 5 to 10 years to Andermatt. So if you don't understand the trend, probably we have somehow missed out talking to the canton to make sure they are allowed to fly there and they're allowed to land. So those are things you need to look at. Or what is the future about hospitality? For example, as said before, if we are having our guests in the Jetty 5-star premium hotel, they see everything around the world and they expect the same in Andermatt. So what do we need to do? Is it self-check-in, self-check-out? Those are already getting commodities, things like that, for example. And then since Andermatt is actually just a winter destination at the moment, and we say, well, we want to have also an offering in the summer or in case there's no snow anymore, what is the future of leisure experience? What do people like to do in their vacation? Shall we go loud or shall we go silent? So those are things we're also trying to explore. And since we're building nice houses, everybody who buys a house in Andermatt and pays, well, kind of a fortune, they really want to have top-notch and want to have the future of real estate in their home as well. And as you understood, the future is based on IT and data, and this is actually why we are here. So we need to create all under this a data and IT layer, which allows our customers actually to have this freedom and enjoy everything at their fingertips, but also, of course, in the nature. And once we have done this, we actually think we should do 2 things. In the end, we become the most customer-centered prime destination. And very important, since we are a service organization, we also must be the prime workplace. I mean, we must have the best people working in Andermatt, otherwise your experience, doesn't matter how much technology we have and how awesome it is, will be shitty. So now again, a little bit of an educational talk. So if you look at now, what is a benchmark from our point of view? And we said, for example, we want to look at the Disney Resort. I mean, they are doing something very good. They oversell everything very well, and they also make sure that everything is pretty seamless and that you feel very, very excited when you are at Disneyland. And here is actually one benchmark we are looking at the moment. It's a little older, I must say. It's not my arm, by the way. So that's the Disney Magic Band. It opens an overpriced, nicely looking room. It allows you to enter the park. It also connects it very secure with your finger, so that you actually don't have to be afraid somebody takes away the goods you bought. It is connected with your mobile phone. You see it's a little an older one. You can enter a fast track because you can, or because maybe at another place in the park you are waiting for hours. Of course, they have also some kiosks around where you can actually add your photos to, or where you can buy tickets for an event. And of course, you also can pay with this. So, and if you look now at this as a benchmark and we say, well, we want to bring this to Andermatt because this is awesome and this might be a commodity sooner or later, and let's break it down and say, for example, this is the awesome Magic Band which we want to have, the Andermatt Swiss Alps Magic Band, which replaces room keys and ski tickets, enables payment, reducing waiting times, offers exclusivity, additional services to guests, and increases the customer experience, and of course, that's why we want to do it, the spending of guests. And if you bring this down and say, well, and now look at it, where are we today and where do we want to be maybe in 3 years, and say, well, this is actually what we want to have as a vision. You must look at it, where are we today, how do we get there, and understand what is your market, what is the product and features you want to develop, what kind of technology you need to understand as a company, what actions, what projects you need to start, and very important, what kind of resources and skills you need. And please, if you look at us and see again, where do we want to go? We don't want to do this necessarily only for Andermatt Swiss Alps. We want to do this for the whole organization of Orascom, so all over the world. And where are we today? We have a ski arena. They have a ticket which you can buy online. So therefore, we started an online marketplace. We put in a little bit of money. We had a project manager and an innovation manager. And suddenly, we have an e-commerce marketplace. And now you need to understand, and this is actually the big challenge for you as a company, or also for you as a startup, you finally have something you have no understanding about. So how should you, as a ski arena, which has people who give you like this, I don't know the English word for bugle, to get on the hill, to run an e-commerce marketplace. So you need to hire those, which means you have to maybe start another project because you have to further develop in, you need to add in more money, you need to add in more skills like a product manager, and of course then you want to add hotels, you want to add your flats you can rent, or your restaurants, or your sport shops, and let's say, yeah, well, let's keep it easy and just do it on our own platform because we can control that. This is quite difficult because you need now to become an e-commerce player. And again, as a ski arena, this is actually pretty hard to do because you have to upskill. You suddenly need UX experts. You suddenly need marketing experts who can actually sell online. This means you need extra money. And yeah, since you want to offer data-driven offers, which is actually the market benchmark at the moment, meaning you must understand technology data. So again, as a ski resort, you suddenly need to start a data strategy project. You need to hire data analysts. You maybe need to start another project which sells this outside for third parties because you want to earn money with this big investment. And if you have third parties on it, somebody must explain to not a smart small, medium enterprises like yours, maybe how this whole platform works. So then you, of course, you want to open this up, so you need third-party APIs, and you need an API, and again, if you have an API, you suddenly need security officers, you need app developers, IT support. Maybe at the end game, if you really want to do this, you must understand a technology you have no clue about, which is called near-field communication, NFC, or RFID. So, and that's actually, and yeah, and once you've done that, then you can start your project. And this is actually the big trick you have, whatever you do. You start from somewhere and you want to go somewhere else where you have no clue and no technology and no knowledge about it. And that's very difficult, especially for corporates. And this is your chance as a startup to disrupt actually the existing players. Maybe as a small example, you know, probably you all know Kodak invented the digital camera, but they didn't have the guts to fire 20,000 chemicals and hire 20,000 engineers to really make this a business, and that's why they got actually broke. And what we want to do here in Andermatt is actually, we want to invite and actually upskill our business, and that's why we said, let's open up our APIs in the first place and find great people who understand technology, how it works, and that's why we have this API. I'm pretty sure you saw last night at Swiss TV the breaking news that we do have this API sandbox, and now I ask Joël on stage because I have no clue about the API, but Joël does. Thank you.
Yes, hello, my name is Joelle and I'm part of the innovation team that is part of Thomas' team as well. And I'm responsible for the sandbox, actually, that's one of my main responsibilities. So I quickly wanted to explain what do we actually have in the sandbox, what do we offer. So at the moment our sandbox is our main customer point, I would say, namely the marketplace that Thomas was also talking about, where we sell ski tickets, we show the webcams, we show which lifts are open, and weather information. This gives us the possibility to open APIs for all of these use cases. And at the moment we're collaborating with Enterprise Bot to actually sell tickets over the chatbot that you can see on the right corner. They are also going to do this over the sandbox, so that is just one example of a use case that can be done over our open APIs. We made this sandbox together with Alturo's destination. They will be there today as well, between 2 and 5. Besides that, we have our main developer platform, where you can get access to all the API documentation, as well as to the test websites that was shown before. So you just need to apply here, fill basic information. For startups, you can also fill some extra information, and when you get access, you can log in on that same website and actually, if it loads, get access to all the API codes that we have and all the documentation. As you can see here. So I will already skip to the next slide. If you have any questions, you can get in contact to our general email, which is digital.innovation@andermatt-swissops.ch, or you can approach me directly. I will be here a little bit throughout the day, as well through Slack, sorry. And if you want to apply directly already to the sandbox itself and get access, you can always scan this QR code. We also have some flyers with the QR code on there if you want to have it for a later purpose. And yes, good luck with the hackathon. And if you have any questions, feel free to approach me.
Thank you, Joël. So, since there's some time left, are there any questions? Otherwise, whatever you do, which is great, maybe you want to add a ski ticket to it. With this API you can. Yeah, good to have you here. Thank you.
Okay, then let's start. Welcome, thanks for joining. I'm happy to be here, and we would like to introduce you to driving IT innovations at the BMW Group. My name is Sabine, and with me is Celine. Maybe you recognize us from the 1 minute pitch yesterday, and moreover, we have Ingmar with us. Ingmar, yeah, here's the picture from Ingmar. Unfortunately, he's not here at Zurich. But hi, Ingmar. Welcome on stage. He will be your tech expert today. Yeah, before we directly start, I'd like to show you this picture. This is our team. We're a very young team and a cross-functional team. And cross-functional, this is, I think, really key to cover the whole innovation process. So Celine and me, we are covering the ideation phase. We are strong in identifying the most pressing business challenges of BMW and mapping these challenges to the new technologies to bring them to our products and services. Yeah, what does innovation at BMW mean? We cover the whole stages from very research-related topics like quantum computing and neuromorphic computing through university corporations, but we also like to partner and to cooperate with startups or other innovative tech and corporate partners. We also do innovations internally, and Celine, I hand over to you.
Thank you very much. Exactly, because that is what our so-called tech offices are there for. And what I think is really special about them is that they are distributed all over the globe to really be on-site and connect with important innovation ecosystems. And you can see it on the slide. We have colleagues, for example, from our team in the Silicon Valley, but also, for example, in Tel Aviv or in Singapore. And then they can connect to talents, universities, but also startups. And what you can also see here is that each of them has a specific technology focus. So when you think of Tel Aviv, for example, there it perfectly makes sense that the colleagues focus mainly on cybersecurity, because also the military support that is given there is really strong. But on the other hand, for example, China, they are really excelling in, for example, when it comes to AI or NLP solutions. And the experts in the tech offices really drive the research for those technologies, but they also do something that is actually really similar to what you are doing on the hackathon this weekend, because that is developing MVPs and working prototypes for specific challenges that we have identified in the organization. And maybe to get that a little bit more concrete, we can talk shortly about a small example. And you might know that BMW is not what you would call a tech company by heart or by nature. So we are over 100 years old, we have the legacy, and we are really closely connected to this industrial setting. So we have large plants, we have a production line, we have huge machines, and it's really a challenge to place also IT-enabled innovations there. And one issue that is really important for us is quality management, because the later we detect failures or scratches in our cars, the more expensive it is getting for the company. And one innovative solution that we have developed in the Tech Office Greenville, for example, is what we call the AI quality gate. And you can basically really envision it as a gate with different camera systems and then software modules and computer vision modules to detect scratches in the surface, for example, and also do other quality checks like, is the color right, are the parts assembled in a correct way, etc. And that is basically placed in the plant on the production line, and in the moment the car passes through, this is directly recognized, which does not only increase efficiency for our workers, but also really significantly reduces the amount of money that we spend for quality issues. But of course, an implementation like that also comes with challenges, especially when it comes to scaling.
Absolutely, because in the end we want to not use it just in Spartanburg, we want to bring it and scale it to all our production lines, and this means for us that we have to empower and enable our employees worldwide to deal with AI, to deal with these new technologies, to be interested in it, and to bring it then into the production plants. And for this reason, Ingmar has established a really great format last year. It's called the AI Challenge, and that's the topic about Ingmar is explaining now. And Ingmar, I would say the stage is yours, and looking forward to that. Thank you.
All right, thank you very much, and greetings here from Munich. So today I want to introduce you the AI challenge. We did this year at BMW. Right side, you see the QR code. So there you will get some more information. All right, so at BMW, the AI challenge has a little bit of history. So we did a challenge 2017 with small robot cars powered by Raspberry Pi. Then there was a huge request for that challenge, so we decided 2018 to go with the Cosmo robot. So that was worldwide available, also for other clients and colleagues around the globe. And then we had, well, no challenge 2019 and 2020 with the pandemic. There was also no chance. So this year we decided to do an AI challenge, and we did that for all colleagues inside BMW. So you see it, we had 435 active participants in that challenge, and yeah, I will tell you some insights about that. Okay, so the challenge was split in two parts. The first part was about picture labeling and training a neural net and check how good that net performed. And the second part was about the donkey car in the simulator. So at BMW, we built those cars physically, such small scale AI cars for trainings. And then we decided to go into a simulation. So for those two parts, we had 472 participants, round about 435 active participants. So we had 89 teams around the globe, 99 departments, and the present in the AI challenge. It was a success, or very interesting for very interesting for our colleagues to participate there. All right, so now the part two, and we set that up. First of all, you join a team, then book the AI challenge, get familiar with the tools, and label some pictures, train a neural net, do a quality check, how your net detect objects in the pictures, and then describe what you have learned and also think about AI use case. So it was, I think, quite easy in the beginning to the topic of AI. It was really no AI, just web services used here. So those web services split in modules. So the first module was the labeling tool. So it's quite easy to install on Windows and Linux. And it runs on CPU, and no GPU is necessary for that. The labeling tool is also able with pre-trained neural net to automatically put those bounding boxes around the information of the picture you want to label. And then was quite easy to configure that labeling tool and set it up for different. So then we had the training. So this one was installed on a Linux server, but could also run on a Windows machine. It's designed to run in Docker containers, quite easy to start and restart them. We used pre-trained neural nets to save some time, so we used them from Model Soup, the TensorFlow Model Soup. And yeah, there's some small problems we will address in the next release. It was not so easy to change your working directory. That is just as a lesson. Then we have also a mass creation of training data. So there's no need to label 10,000, 100,000 pictures per hand. So we can scale that up quite easy. So on the right side, here a picture from the labeling tool. Today I want to show that live, but I'm not able to get to the BMW network and running that live stream here. So I have up the VPN connection to BMW, and so it's just no possibility for me to show it live. So we only have the pictures on the right side. So when you have labeled your pictures, then you go into the training feed. So you see that in the lower right corner. So you do not need to think about hyperparameter tuning, but it's also possible if you're familiar how the nets from the models are designed, and if you are maybe more a professional user, then it makes sense for you to do hyperparameter tuning, but not no-code AI. And as a part of that training suite, there's also current API, the Swagger interface, where you can the neural net and get feedback how good it predicts the information on the picture it detects. And then very, very new evaluation API, so that makes it easy for us to do some automation and optimize training. So we are able to say a specific class needs retraining, so we can do that automatically, and that the process figure out which parameters are the best, get a very good prediction. So in the our left corner, you see that the labeling suite, the training suite, and the evaluation API. Everything or every of those modules are looking on the same drive or data. So it's quite easy to label new pictures, do some retraining, or to automate the whole process of the evaluation API. So we had a bug bounty program during the AI challenge. So our colleagues detected 16 bugs and 184 enhancements. So we implemented those enhancements and also fixed those bugs. And yeah, it was a successful bug bounty program, and the modules are also published as open source on GitHub. The link will be shown on one of the next slides. And yeah, so our target is to develop those tools with new features and also optimize that automatic retraining process. So here are now the QR code with a link to the GitHub repository. And on the right side, a very cool repository, the anonymization API. So there you could upload video and then put bounding boxes around people and blur them out, or to do those inferencing as well. Then it looks quite nice, like shown in the right lower picture. So, and we also have some stereo API, semantic segmentation. We are using the annotation API, optical object recognition API, and that published on the GitHub repository from our tech office in Munich. All right, so that was about the first part of the AI challenge, and then we had the second part with the donkey part. So that was more our BMW DNA to do some challenge. So it's also open source software stack we used here with the Unity engine and the Donkey Car framework. So if you are not a part of the team, so then you had to join a team to participate here, install the Donkey Car framework on your BMW computer or maybe private computer, then get familiar with the Donkey Car framework itself, and then record some training data in the simulation. So what we are doing here is behavior cloning, then train a neural net on base of the data you recorded. Then you have to test your neural net, how could it perform on the racetrack, and then maybe do some additional reporting to optimize the neural net, and then do some competition against other teams to see how good your net performs in comparison to the other teams. And also, it's important to show in your training data also cars on the racetrack. Otherwise, the neural net is not able to deal with that information, that an additional car or more than 2 cars are racing around what can do with that information. So you need also the training data. Well, and when the team had the feeling, okay, we are ready for the competition, then there was a time slot with a deadline where they had to register for the competition and upload the neural net. And then at the end, did a knockout tournament between the teams on a server central here in Munich. And then we had the at the end the winner team. So just a short overview here. We use the Donkey Car framework with the Donkey Car Gym extension to have that simulation running. Or we use behavior cloning. It's also possible to do some reinforcement learning with that simulation, but that requires more understanding of AI. And we did a no-code AI challenge here, so behavior cloning was quite easy to understand. And then we had a process set up that we are able to train a neural net for our team centrally. And only had to upload the data. We are able to create videos, how good the trained net and performs on the racetrack, and give those videos back to the team, so that also reduced the time for the participants they had to invest in that challenge. And we could also do some neural nets racing against each other. So there the teams could select which net should race against their own net. We also created a video of that. Okay, at the end we collected 197 gigabyte of training data. We trained 435 neural nets. 28 teams participated in the knockout race. And the fastest lap time was 29 seconds. And the team which won that knockout tournament, they need 30 to 31 seconds for a lap. So not the fastest car is not the one that will win at the end. Then we did a short test. We put the data from the best 8 teams together and trained a neural net on basis of that training data. Conclusion, the net was very stable but not fast. So you would never win a race with such a net, but it's safe for the people sitting in the car. So we show a few seconds how that looks like. So I hope you see the screen. There's no audio. So the upper car is the car trained on those training data of 8 teams. The lower left one was the car which won the tournament, and the lower right all net the net which did the second place in the tournament. And you see the upper car is very stable on the racetrack, but not so fast. The think tank 1 in the lower left corner is fast and on the racetrack. and Hailport 2 in the lower right corner is the fast neural net, but not so stable on the racetrack. And that's how it looked like when we did the races. So we have everything published for you on GitHub. So there are the APIs we developed from BMW Innovation Lab. And we will also publish there the updates and enhancements, and in the future some new APIs we are currently developing. And I wrote a short ebook and published that in my blog, and it describes how to set up the donkey car simulator and to build such a car. All right, so if you're interested or have also some questions, so feel free to contact our team, AI Challenge at BMW. So there you will get answers from us. And I think I was quite fast because of the missing live demos, so we have some time for questions. So, not sure if Ina, Celine will go back on the stage.
Doesn't seem like that. I'm not sure about the chat. Who can see that one? Ingmar, can you see the chat if there are any questions?
Yeah, but the screen is a little bit far away from me. So. Okay, but there's no question in the chat. I only see the discussion with the host.
All right. Then I'd say Sabine and myself, we stay on site for the next few hours. Whenever there are questions at a later stage, just hit us up. And as Ingmar just mentioned, feel free to reach out also via mail or connect with him via LinkedIn, etc. if there are any follow-up questions. Thank you very much.
Yeah, or
and
via
thank
the
you,
GitHub
Ingmar.
repository. It's also possible.
Sorry, could you repeat that? It was hidden by applause.
Or via our GitHub repository where we publish all those APIs from the TechOps community. So that's also possible.
Sounds perfect. Thank you very much.
Then, thank you very much and have a good time in Zurich on the hackathon.
Michał, and I'm here representing Valora, and I would like to talk to you a bit about our experiences with using F# for our backend services. So, as I said, I'm a software engineer. I'm leading this new team that we built at Valora around a year ago. And, but first, I might tell you a bit more about who Valora is. You might not have seen the brand Valora, but you might seen one of the brands that belong to Valora, especially if you're in somewhere in Europe, in Switzerland, Germany, Luxembourg, or wherever you might be. So we operate in the areas of retail and in food services. So here in Switzerland, for example, we have Brezelkönig avec and K-Kiosk, and in Germany, Backwerk and Ditch, for example. And we are active in Valora Digital, which is it's a new product development and innovation unit that is interested in topics like autonomous stores, loyalty, payments, e-commerce, deliveries, and different internal process improvements. As I mentioned, it's a pretty new unit that we have at Valora Digital, which was founded in 2019. Our engineering team, actually started last year. And to start, we had to kind of figure out what do we want to use to develop all the services that support all our products. So we ended up with a tech stack that basically looks a bit like that at the moment. We are using .NET and F# to run our back-end services. We run our services in the Google Cloud. We use Terraform to manage the infrastructure in Google Cloud. On the front end, we're using native technologies. We are using Swift on iOS and Kotlin on Android to develop native applications. And we use TypeScript on our web front ends. All of that is joined on GitHub, where we use it for our CI/CD needs as well. So this talk will focus on the F# part of our tech stack. So what is F# for people who have never maybe seen anything written in F#? This is a Hello World application, console application written in F#. Nothing all too fancy here. Some similarities to other programming languages, but nothing far from what you might have seen. The language itself was developed in early 2000s in Microsoft Research Cambridge, and it's, as I said, running on .NET platform, and it shares this platform with languages like C# or Visual Basic .NET as well. Yeah, but so our developers are already using it, as I said, already almost a year. And we have noticed in this period of time that we have particularly low amount of runtime bugs that we have to deal with. We are pretty confident that what we deploy actually works as we anticipated. And we are basically enjoying also developing using this language, which I think is pretty important. That gives a bit of an additional fun element to the job, to your everyday job. So that's all well and all cool, but Valora is a business. We have some business problems to solve. So how does F# help us there? Yeah, exactly. Why F#? Why did we choose F#? So I will present to you three main things that we think help us along the way. Of course, these are just very high-level views of the topic. So firstly, domain modeling. Every business has their own domain. They have some vocabulary, something that they are working on. And if we are able to translate this domain into code to kind of make this domain model as close to the actual business domain as possible, then we basically can solve the problems much easier, much safer way, and much more correct way. So what I mean here is how F# helps us here is it provides two types of data types, two kinds of data types. Firstly, you have the records. They model the end relationship between different data elements. So here, example is like we have some PayPal data, some Twint data. They only contain one element in them, but we also have credit card data that contains alias and type and masked number and expiry month. So this is the end relationship. This looks pretty standard if you're coming from any other language. What we have on top of that in F# are those so-called unions. So these unions are modeling so-called OR relationships. Here you might have noticed that in the credit card data I used the credit card type model, and this credit card type contains one off. So it's either Visa or MasterCard or American Express and so on. And of course we can also use this kind of relationship to combine all the payment types in this case into one payment method, something that represents a payment method. So a payment method may be a credit card, it may be a PayPal, and it may be Twint in this case. So you can imagine that with the combining ands and ors, in this case, in this way, we can really model our business domain to a very precise degree. But we can take it even further. So as you might have noticed, I've used here a lot of strings. So alias is a string, masked number is a string. So what happens if I create such a record and I mix up the two? So compiler is telling us, yeah, that's not a problem. In F# we can create a wrapper around such a type that will say, okay, payment method alias is a type that has a string inside, and credit card mask number is also a type that has a string inside. Now we can use this in our model, replacing the strings, and if we mess up something while coding and try to put credit card mask number into an alias, the compiler will tell us just no, you cannot do that, there is a type mismatch there. So of course we can go even deeper, but that's for another time. Yeah, there is so now you have to act on this domain model as well. So here we can use the very powerful pattern matching features of F#, where, for example, if you want to validate this payment method, we can check if it's a credit card, then do this. If it's a PayPal, then do that. The nice feature of this is the compiler checks the exhaustiveness of these pattern matchings. So if we forget to match on to handle the, say, Twint case, the compiler will tell us, hey, you are not checking, you are not covering all the cases that you defined. This is particularly nice if you're adding a case afterwards in your code, after you have already existing code base, and the compiler tells you, okay, you added this this new case, but you have to handle it in all the other locations. So once we have those functions, we can also chain them together into something in the data processing pipelines that are very easy to read and very easy to understand. So we have this pipe operator, which is just like a Unix pipe. You pipe the result of one expression into as a parameter of the next function that returns another expression. Yeah. So second part that we like about the F#. Safety. This is about the features that F# gives us to guarantee some kind of safety, and about the features that it does not have that also guarantees that we don't do things that we shouldn't be doing. So firstly, I already talked about this. We can create those type wrappers that prevent us from calling functions that are not supposed to be called with some other type. So here we have an email address concrete type and a function that expects this type instead of a string. So if we try to call the method with a string parameter, we will get a compiler error. Another one is values in F# are all immutable. So if you assign 42 to X, you cannot then change this. So here in this example, X is if you try to do the mutation, the compiler will tell you that you did not mark the X variable as a mutable element. The same goes for records. You cannot just change a value of a record, of a field in a record. You cannot just say, okay, it was some name and now it's the other name. You have to create an entire copy of this record with this value changed. It prevents the entire category of errors where you are passing an object or data structure into some kind of function, and you don't know if it gets mutated in there or not. So this entire category of bugs falls away. Another very cool thing about F# is it doesn't have the concept of null, which is a bit of a lie. I will get to it later. But if you're writing F#, you cannot just assign null to something. If you're coming from the C#.NET background, it seems natural if something is string, of type string, you can assign a null to it because it's just as an uninitialized or missing value, however you want to interpret it in the situation. In F# you have to use explicit option type where you say it explicitly if it has a value or it does not have a value. If the type is not using the option type on it, you always are guaranteed that this is not null. So third of the things that we really like about working with F# is its ecosystem. So it's kind of nothing about the code, nothing about the language itself really does. It's about it being on the .NET platform. So even though the F# is not maybe the most popular language out there, we do not have to reinvent the wheel every time we are touching something. We have access to over 250,000 packages on NuGet. We have access to, we can build on top of ASP.NET Core, which is a very high performance web framework that Microsoft just does amazing things with. We have, we benefit from all the improvements of the .NET platform. In fact, there will be a release of .NET 6 coming in a month or so. And last but not least, of course, in F# itself, the ecosystem is really, really nice. The community is welcoming, it's thriving, it's small, but it's very, very welcoming, and you can ask any questions to the members of community on the F# Foundation Slack, regardless if you are a beginner or if you are already a very advanced F# user. So yeah, it looks awesome. Like why isn't everyone using F#? I don't know, but there are definitely some caveats that you have to have in mind when you're going this direction. I'll talk about two. So first, interoperability. So this is the thing that I said. It's a very it's an advantage of using F#. So you have the access to everything that was written in C#. You can use the libraries. You can be on the you can use the frameworks and everything. So this has a cost though, and you have to be aware of that. So remember I said that I lied that there is absolutely no value, null values in F#. Well, there is a situation where you can have null values, and it's exactly when you're consuming libraries that were written in C#, for example. And if such a library decided to expose in their API some nullable value, well, then you have to really you have to be aware of that, and you have to catch it in the place where you are interacting with this library. Another such a gotcha between this in the interoperability area is the default equality between objects. So in F#, data objects by default implement structural equality. So they really go through every element of the structure and compare them, and only then is the one element equal to the other. C# defaults to reference equality, just checks if the object that you're comparing to is the same as the other, like on the reference level, basically. So you can, if normally it's not a problem, again, it can be something that suddenly comes up, and you have to deal with that. Another thing that's not ideal, I would say, is the story about tooling. And here is a big kind of caveat. If you're coming from C# that has stellar tooling, it has all the years of Microsoft JetBrains working to support this, yes, then it's a bit of a downgrade. The compiler is a bit slower, the debugger is maybe not as granular as you would like it to have, and there is no fancy refactoring features in the IDE. But honestly, coming from any other direction, the tooling ecosystem actually looks really nice. So you have Visual Studio, you have JetBrains Rider, you have Visual Studio Code with a very good F# support that's completely community-based, community-developed, and it just continues to improve with time, and we are now excited for the new release of F#6 that's coming along with .NET 6. Yeah, so kind of it's a very, very fast and very, very high-level list of things that we do like and we don't like. But in general, we actually really, really enjoy working with F#. It really allows us to model our domain in the way that we really like, and it allows us to be sure that our assumptions about how the business is working are correct. And we can then validate even if the business side has holes in it, because we don't know, some things are maybe undefined, some things weren't talked about, but we caught it in our domain model. And this domain model told us, hey, for this thing, we actually don't know what's supposed to happen. So, I think I was a bit faster than I thought I will be, but I want to thank you. And we are at Valora booth the entire time, so you can come by if you're interested, talk to our engineers, talk to me, and or catch us somewhere on Slack or whatever you are. There are some very good resources online on official Microsoft websites or community websites. So really, I encourage you to just go out, try, and have fun with it. Thank you.
Much for joining me today on this talk on how I learned to love test-driven development in Go. I'm Andres Bott. I'm a software engineer at Adobe in Basel. I'm currently working a little bit over 5 years in Adobe. I've been doing different roles from support to internal support and different roles. But lately I've been working in reliability engineering and deployment engineering. And here is where I really learned to love Go and test-driven development in Go. About the agenda of today, I'm going to talk a little bit about Adobe in Switzerland, what we do. Then we will transition towards release engineering. This is a small overview of my day-to-day. And then the final main topic of this talk, the test-driven development in CI/CD code for written in Go. Let's get started about Adobe in Switzerland, Adobe Engineering in Switzerland. So most of you in the audience probably know the Creative Cloud solutions, Photoshop, Lightroom. Some of you might know the Document Cloud, which is Acrobat, PDF, but very few of you probably know the Experience Cloud. The Experience Cloud is basically one of the pillars in Adobe that's focused for solutions for big companies. And most of the engineers in Basel work on Adobe Experience Manager. Adobe Experience Manager is an enterprise CMS, so content management system, and web application framework. It is built on top of open source projects, big open source projects, and since a couple of years ago, it's also available as a cloud service. Even if you don't know it, or if you're not aware of it, you have probably already used or navigated many of the websites powered by AEM, since many of the Fortune 500 companies use AEM as to generate and manage their websites or their digital experiences, as we call it. As for the tech stack, about the open source contributions, we have a big foot in the Apache Foundation with big projects like Apache Felix, Apache Oak, Apache Sling. These are the open source machinery that power our CMS under the hood. We have the team lead of Apache Felix is working with us on this product, and also a special mention Magento, which has been a recent acquisition, and it's powering the digital marketing, so online shops and all these back-end services. Talking a little bit about AEM release engineering, and release engineering very specifically in AEM. So we have hundreds of engineers contributing to a common code base. We have a constantly set of pipelines running continuously. As you can imagine, there are many moving parts involved. There's a very complex system where we have many incoming requirements, both technical and from the business, to coordinate and validate all this deployment for this for AEM, this big product that we produce. As a consequence of this complexity and all these moving parts, it has become very hard to troubleshoot and to identify problems or even avoid problems before they actually happen or we deploy code into production. So this is where we, as a team, decided we want to move to a different kind of programming language, and we decided to go with Go. So we are moving away from what's the classical or what you would find more often in CI/CDs, Groovy in the case of Jenkins code, or simple Bash. Benefits that we found when using Go as CI/CD code is easy to test, easy to read. So if you ever think, yeah, you just write a small Bash script, I hope it's big enough so you can read it. This is a small sample where Bash is completely fooling you to think it's behaving completely different. I'm not going to go through the example. You can find many of them online. And also one benefit that we found on Go code is that it doesn't depend on a platform. So for example, in Groovy code, you always need to push or change the code on Jenkins and then invoke the Jenkins directly. This is very, very tedious. Or having a local Jenkins is also very tedious. So we decided we want to have a easy testable language that we can run automatically locally before even validating any next step. A quick word about Golang. It's a compiled language, it's statically typed, garbage collected, and in the end you get a small executable binary that you can execute and just run your code. As for the bash example, you can imagine this is an example from real world. You can example a very simple commit. We only see 2 lines, but this actually broke our CI pipeline. These 2 lines actually caused almost 1 day of troubleshooting, where the problem was simply that the developer that added a new positional argument, but when invoking the script, the positional arguments were flipped. Therefore, the values in the variables were populated incorrectly, and then the script behaved completely randomly on a completely different place in the pipeline. So troubleshooting this and finding the root cause of it was very tedious and took a lot of time. I really think this could have been avoided if we would have had this script in a different language with unit tests and better support. So this brings us why we decided to go with Go on the language. And now I want to go to the main part of this talk, which is the path towards test-driven development. And this is really how the path on how I found this aha moment that we all have when we start writing code, that we suddenly understand something and we say, okay, now I get it. Now I understand what's happening here. And this is my story on when TDD for me suddenly was, aha, now it makes sense. For those who don't know, test-driven development, so this quote is from Wikipedia, is this software process where you start writing your tests before you actually write the implementation. So this means you define your business case or your technical requirements as a test case, and then you make sure that this test case actually fails to make sure that your code works, so the testing fail is a correct execution of your code. Then you move forward to write the implementation of your code. You verify that this implementation fulfills your technical requirements that you have already defined in your tests, and then you do smaller refactoring and iterate over this process until you have fulfilled all your features that you want to implement. To make it a little bit more simple, we will go with a sample application with a very simple use case. Please note that the code samples that I will show are very simplistic. They omit errors. They are really only to showcase the path and the evolution. So for this example, I'm gonna write a application. So our PM, our product management, came in and said, okay, I want an application that reads a value from an input, performs an API call, transforms this result into something different, and then prints the output. Very simple, seems quite straightforward. So I start writing. I say, okay, let's do everything in this main function. We don't go much into the details. I hope you see the pointer. So we start with the input. We read the positional input on the argument. With this positional input, we do an API call to an external service, in this case, example.com. We get a JSON response. We get this JSON response, transform it into a struct, into a data structure. We do a string to integer conversion so that we have a real number, and we basically print this number. So we have fulfilled the technical requirements from our PM. Simple code, we can compile it, we can deploy it to production and run it. Okay, day 2. So next day, our PM comes in and says, okay, look, these requirements have changed. Now we need to have a little bit more interaction. Our upstream server cannot handle the request synchronously, so we need to do an asynchronous process. So we need to call the API, but instead of getting directly the response, we need to wait until some upstream process finishes. So probably we need to implement some polling. And then, of course, the response might give us different values, and we want to print the output depending on the response that we get. We might get a execution timeout, maybe an error, or different kind of responses. So, okay, let's do this implementation again. We are here. This is the first part. So where we had before the synchronous API call, now we add a asynchronous step. So we do a loop. Please keep in mind, very simple. This is not real world code, but you get the idea of the point. We're still not doing TDD, by the way. We're just following this process. This is the transformation. So we do some code transformation. Depending on an error, we print job failed. If we get an actual value, we print the value and the job status that it's successful. Okay, at this point, we see this code has been growing and has been already a little bit harsh to maintain. In the real world, of course, this is way more complex. You have many, many more layers of libraries and situations that make this bigger than just these 20 lines of code. But anyway, I decided, okay, I will extract the transformation of the data into a separate function. So this function now takes care of this transformation. And you know, since we're doing these things right, let's write a unit test. We know that testing is important. I'll write a unit test to cover the functionality of this unit test. Still not doing TDD. I just decided, okay, let's extract this function to make code easier to read and add some unit test coverage because unit test is important. So, day 3, our PM comes in again, new requirement. We need to store this output that we get from the upstream server into a database. So, at the current state, we have a code that is running in production. It's partially unit test covered. I know I learned already how to write unit tests because I just did one to cover the use case. But I realized the following. The moment I want to store data into the database, either during the development process, I can either decide to execute the whole process that includes calling the upstream server, waiting until it finishes, and then getting the results back. You can imagine, if the upstream service takes 20 minutes, a simple code change takes me 20 minutes. So this is not really ideal. I want to continue with my code. I want to make sure that I am able to write into the database. So what's the first option that comes to my mind? I go in, uncomment the upstream response, and I just hard code the value into. So I am temporarily disabling parts of the code in the main function to invoke the store to database function. Who has done this in the past? Hands up. Well, awesome audience. Well, this is a possibility, definitely. But it has a problem that you need to revert those changes later on. And on a simple code, it might work. When you start to uncomment and comment out, when you start to comment out sections in multiple libraries and you need to take in consideration all the implications, it suddenly becomes already quite a lot of work just commenting out all these sections. So instead of that, I decided, okay, let's try it, just a test. The test can be as simple as we put the values there and we call the function. So now we have a test. Remember, the store in database function that we see here has 0 implementation, but we already have a way to call that function or this method in an isolated way without calling the upstream service, without any other implication. So we are only focusing on the feature, store data in database. At this point, you can already start implementing the first steps of the function, or if you want to be a purist, we can do a little bit more and we go and extend the test to read from this database. Currently, the function doesn't write into the database, but it reads from it. So the test is reading from the database. That means in the moment we execute this test, this will fail because the database is empty, it doesn't contain the value that we're expecting. This means we have written a test that defines the technical requirement, store in database, and have not yet an implementation. At this moment, it's the perfect time to start writing the store in database function. And with this point, we have made the first step of test-driven development. We have written a function that defines this use case, and now we can focus on the implementation. Of course, this is always an iterative process. This first process only stores one data point. We need to iterate over it and need to improve over it. And this for me was really this aha moment where I realized, okay, I'm faster by writing a small test that invokes the code block that I want to add as a new feature, and then I can iterate over it. Some benefits and myths about test-driven development. I hope you have already seen where I went and why I think test-driven development is actually quite beneficial. General myth, when I speak about people about this, they say TDD slows me down. I need to write first the test. But as in the position, on the other side, I say, look, if you need to start uncommenting so many code blocks and you need to make so many changes to actually write your code, I think it's faster to write a small test. You don't need to have 100% test coverage. You just need to have a test that covers your use case, the business requirement that your product manager or your customers are expecting. And indeed, in that way, you have a fast way to invoke your function and invoke your feature and make sure that it works as you expect. Also, on the long-term maintenance path, it helps a lot on troubleshooting. Having those test cases and being able to rely on the whole system being tested allows you on the long term. It helps also on troubleshooting to see the test, see how you can set up a tracer, something like that. What I also find very interesting is the tests on its own express the intent. So there was a very interesting talk some time ago from Google where I remember this sentence: if you like it, put a test on it, making reference to a famous song. Basically, the intent or the idea behind this is that you express the intent of your use case as a test, and when another developer comes and wants to make a contribution and he changes something that he doesn't think it will have an impact, the test will catch it and will cover your use case. And then the developer knows, oh, look, there is somebody who actually had this intent, so let's focus on this and make sure we don't break this feature or this intent that is defined there. Of course, some benefits that we get tests for free, which is super cool. So we already have the test. We don't need to go afterwards and say, okay, now we should have added a test for this. But you already have the test covering your use case. And what I also learned very interesting is, since you start with, before writing code, you start thinking about your code, how you're going to structure it to be testable, you end up writing better code because your code structure makes more sense, it's more isolated, it's more modular. And in the end, I learned to become a better developer when writing test-driven development. Since we still have 5 minutes to go, I have a small bonus slide, which is why I think tests in Go are great. This is not really specific to test-driven development, but rather to the Go language on its own. So tests in Go are built very quick. They are compiled and executed in a couple of milliseconds, so nothing like 10 minutes waiting for the test to be executed, but really, really fast. They have some built-in mechanism to actually cache tests, executions that have not been affected, and that accelerates really the test execution during the development. Then, of course, before making a commit, you run the full test bench, which also runs very quick. The test framework is built into the language, so the designers decided to build in tests from the beginning. One very interesting idea is that you have testable examples. So when you write documentation, you can also write small example blocks to showcase how you should invoke your library, how you should invoke your code. But those example codes are also executed when you run Go tests. These are testable examples, and they're very useful. I use them personally for doing integration tests, or maybe sometimes end-to-end tests, depending on the scenarios. But it's very useful to have also testable examples. So you make sure that the examples that you get two-sided benefit. You make sure on one side you test your code, but you also make sure that the examples that you push to your documentation are actually working. And built in, we have benchmarks, which allows you to calculate, to get some performance benchmarking, and there are some utilities to identify race conditions that are very useful when you start to work on concurrency models, and I hope you do that because it really helps on performance on the Go side. Thank you very much. We are almost on the end of this talk. Some minutes before end, so I'll just invite you to join us on our booth on the Adobe stand. And I hope you enjoyed your talk. If you want to come by and have more information, small details, feel free to speak with me or to stop me on during this hackathon. And if you don't agree, come to the booth and change my mind. Thank you very much. I'm Andres Bott, and I hope you enjoyed this.
Last time was in 2018. It was a little bit different. I'm actually currently looking at a pretty much empty room, which is great for my nerves. But obviously, saw a lot of people looking at this online and staying safe. That's great. Yeah, excited to be back and excited to be presenting about these opportunities that now are available to developers like yourself to capitalize on this market. Let's have a quick look. So today I want to talk about beyond open banking. Open banking, when we talk about that, usually has to do with the regulatory changes. They're requiring banks to making the data available to third-party providers. But I don't want to focus on the regulatory stuff today. I want to focus on opening up all bank data, all your data, because at the end of the day, this is your property, and you should be able to decide who and how this data can be used with third parties that are of interest of you. Financial institutions are looking for guidance and are eager to co-innovate. Obviously, now with the shift to open banking, they have the possibilities to expose data that was previously dormant behind a core banking system, extremely hard to get to. You're not just going to provide a JDBC connection to any third-party software to go directly on the database of the bank. Obviously, with the rise of APIs and exposing these data to services that have previously never had the chance to. Huge possibilities there. And they're obviously very eager to work with us, with you, because all these years they've been focusing on providing financial services to their customers, and they really need fresh ideas. They need developers to actually implement these ideas, and a very exciting time all around. As I said, previously all this data was locked behind monopolies of financial service institutions. So, in the case with Avaloq, if you wanted to develop on our system, you basically had to spend like 40,000 on a certification, do a whole month of training, and then you had like the basis. And maybe, to onboard a new person can take 3 to 6 months. Obviously now that we are exposing this data in a way that doesn't require you to be directly on the core banking system, it opens up the market to new developers, new talent, and fresh ideas. We also talk about a gold rush for banks. Not only are they competing with digital-only services, they're also competing with each other. Banking is more and more being seen as a commodity. I'm a prime example of this. Over 10 years, I've been working in finance and software development in finance. But my banking needs are actually quite simple. I've got my debit card, credit card, savings account, and the dritte Säule, which is something specific for retirement fund here in Switzerland. But other than that, I basically have a bank account to receive my salary from my employer and to connect it with the payment apps that I actually use. So like Google Pay or PayPal. And moving money to like a crypto exchange. But other than that, also being half American, I'm always a bit nervous to talk to my bank because I'm afraid they're just going to kick me out anytime. It's a bit difficult. I recently switched, and it's not easy for, I would say, expats opening an account here in Switzerland. So it's good that they're focusing on new services on that. Today I'm just going to show you about all the opportunities that are now available to you. Avaloq itself has over 400 main APIs. Our engineering department has told me that we actually have over 7,000 APIs, and all the data is up for grabs, and then it's really just up to you how creative you can be and finding creative use cases for all this data. So first, I just want to give you a quick introduction to APIs and wealth management. Obviously, as I said, open banking is being pushed by regulation, mostly in the European Union, not so much in Switzerland, but FINMA, together with an organization of fintechs here in Switzerland, and the governments, they're all working now together to also propose potential laws or things that banks are going to be for or are going to be asked to comply with, to then also open up this data so that you can use your data the way you see fit. Client expectations obviously changing with all these digital-only services. I was quite surprised when I set up my Revolut or moving money to my crypto exchange. It was surprisingly easy. I had done 2 customer onboarding projects previously with like major banks. And I mean, these were like 1 to 2 year projects, highly complex, and we thought we had a really good workflow and everything, but then I look at these digital-only services and it takes maybe a couple minutes or an hour, and I'm also onboarded, and it's quite it's humbling. It's also extremely exciting to see how regulation and how people that are not traditionally from the banking industry are changing the market, basically. But obviously APIs is nothing new for banks. Most of these interfaces are old enough that we probably never even called them APIs. I'm talking about the reason why it takes a full business day for you to wire transfer something to another bank, or why you cannot do that stuff on a weekend. I mean, these are ultra secure, robust, time-proven message interfaces between the banks, even though there's now straight-through processing, which I don't really understand why I have to wait till Monday till my money is gone, but I mean, it's just something that's historical. In the second step, I mean, Avaloq and also other competitors, we've introduced frameworks to basically let banks expose exactly what they want and do exactly what they want. The problem here was that this was, again, based on proprietary technology, so requiring special certifications, special access to access this data, and you were basically starting from scratch. You didn't have like a person API where you could just get name and address of a person. It was really written in a proprietary programming language. It's highly flexible. You could really achieve anything you could ever think of, but it was just, I mean, the amount of effort it took. Also, I mean, scalability was a huge issue. If the core banking system is down, this system did not work. So that's obviously no good. And you need to have this actually, I mean, you always want to have it separate from the core banking system. So also web banking, you are never accessing the data directly on the core banking system. There's always like a front database or a cache database, and then the core banking system, and there's replication that happens between the two, because obviously if you get DDoS attacked, you don't want the core banking system, underlying core banking system, to be affected, because I mean, these are highly complex systems. They do jobs, end of day jobs, end of year jobs throughout the day. I mean, you can never interrupt basically the core banking system, which is why everything needs to be separate, which brings me to now the final evolution of APIs in banking, which is no longer based on proprietary technology. We're using complete open source stack, and we deploy it in the cloud. Gives us 24/7 availability. We don't need the core banking system to be available, so it can handle disruptions through a read and write cache. And they're much easier to work with. Again, no longer proprietary programming language. We use GraphQL for defining which data we want to replicate. And also, if you want to make your own endpoint, GraphQL is like a templating language where you can then basically say what fields interest you. So if you're building something that needs customer data, you could build your own custom endpoint within minutes that just displays first name, last name, address, for instance. It's you no longer need that deep banking knowledge or certifications to do that. Obviously, all the documentation's in Swagger and very easy to work with. So some of the goals and benefits that are now coming with obviously liberating this data, making it available to more developers out there. Innovation is now the key business driver. It's no longer a lot of projects that I do, it's just they need to upgrade to a certain release, or they need to comply to some regulatory requirements. Banks are really now hiring also new people to come up with interesting, fresh ideas. And innovation is now the driving factor, no longer cost, and it's all about obviously user experience. A massive boost in agility. Again, if you can start developing the app without going to a 1 month long course, getting that certification, you don't have to wait 3 months. That's a huge boost for getting developers on board, for getting you guys on board. Also for the bank, because they no longer have to worry about, or have to worry less about, providing you access to their systems. Avaloq also has a sandbox environment where you can try out your application, consumer APIs, and see what you can come up with. And that was previously just not possible. Integration complexity is also largely reduced because, I mean, there's no clear standards for APIs in banking. Obviously, all the regulatory stuff, that is very clearly defined. These are public APIs. The standards are defined by the law, by the regulators. But here, even, I mean, most of you can probably just look at the documentation and figure out, okay, I need an address, I can get it from the address interface, or I need person's name, it's the person's interface. No, it's much more easily digestible, easier for you to integrate with. I mean, time to market, we have a massive decrease in that. Because we have all these tools, we have sandboxes, we're able to provide the information, the data, in a much more enjoyable form for you to consume. So that's great. I'm actually currently doing a massive bank migration. It's like a 2-year project. And the hoster basically needed a month to set up the database for us, for the core banking system. But within like 1 week, I already had basically my constellation for OpenShift completely done, ready to deploy. And also the front end, which is now Angular single page application deployed on an Nginx Docker image. I was already able to basically put something together while I was waiting for the thing that we actually needed to progress, which is very exciting. I mean, obviously, rapid prototyping is now much more viable and easier to achieve. I mean, many times we did projects where, you know, we're just looking at a picture in PowerPoint and then discussing that. Now, I mean, developers can really just go in, change something, you know, rapid prototype, and get instant feedback from the customer. Works much better with our agile mindset, and not going the traditional route of building something and then after 2 years coming back, well, actually, we wanted it different. Obviously, huge customer feedback loops involved, and for everyone, it's a much more enjoyable experience. We also talk about higher efficiency. So especially, I mean, obviously you don't have to build these endpoints from scratch. We have existing ones. You can modify them to your needs, make your own, all with just this GraphQL language. Just makes it much easier to just get something out there. And customers can now fully leverage their data. I mean, they're quite surprised about how much data they have, and I was also surprised. Later on, I have a little story to tell about too much data. But I mean, yeah, they're looking for guidance, they're looking for assistance. If you have an idea, innovative way of combining their data with other data in the ecosystem, you know, they're obviously very willing and interested to work with you. And of course, to improve customer centricity. So as I said, I mean, rapid prototyping is now, I mean, 30 times faster or more than previously, and gives me a lot more time to then work with my stakeholders, working with marketing department, and really nailing the full user experience down, which is something where previously lots of lead time until we were actually able to show something that was representable. Yes, so new products and services driven by these APIs. I mean, obviously big data and AI are huge. I mean, most of these API projects that I'm working with, they're basically taking the data out of the core banking system, putting it in a data lake to be processed then by other systems. Now, this could be for fraud detection. I mean, just think if you have all the customer transactions available to be read. If someone suddenly has a transaction in a different country, it can be flagged as maybe fraudulent. Then it can also go back and see, well, maybe this person rented a renter car or booked some flight tickets. That would explain why he's suddenly in a different country spending his money. I mean, there's unlimited amount of ideas that you can obviously, I mean, these two buzzwords together, it's just, it's hard to pin something down, but that's just one of the examples that I see currently being implemented. Obviously, You can give customers a lot more control about how their data is used. So this is not something that's currently available, but maybe in the future, I mean, now you go to a website, you want to register, but you don't want to type all your information down. You can just sign in with Google, sign in with Facebook. Maybe in the future, you'll be able to do the same with your financial data. That, financial application wants access to your current account balance in the last 30 days of transactions. And that's something that you could then maybe manage for a one-shot authentication, that it gets it once, or have it somehow tethered, two-factor authentication, or managing all your authorizations on maybe your web banking of your bank. But these are all ideas that are floating around. I mean, quite funny, I found this app, it's called Clio, a chatbot. The company says, I mean, again, no relation to Avaloq, it's just something that I found quite entertaining. It's a money app that doesn't suck. And basically, I mean, it helps you save money, it gives you recommendations to save money, to get a loan. But the whole interface is built over this this chatbot that's actually quite sassy. You can tell it to roast you. It will use expletives and it will always respond with really dank memes. So it's definitely something that has come out of obviously a market that is not the bank. I mean, I can just imagine this pitch meeting at the bank, just our new mobile application is going to tell the customer to go figure this out. And it's really interesting what developers are now doing with all this data. And yeah, I mean, there's a bit of an older story, but I mean, there's this really novel loan app in China that combines financial data with other data. So people that don't charge their phone that often are less likely to pay their bills on time, and they can basically use information like this together with your financials to figure out what kind of risk profile you have and give you a loan that would most or best fit you, or a bank in that case as well. So coming to the challenges, I mean, obviously financial privacy is here key. I'm logged into so many websites with my Google or Facebook account, I don't even remember. I mean, obviously if this would ever come, then for wealth management and banking, this would be a huge challenge to tackle, not just for the banks, because I mean, they're obviously the liabilities for reputational stuff like that is huge. I don't know, a lot of people from international crowd here, but Inside Paradeplatz is like a website that basically, uncovers things that are happening in the financial market. And if you're a bank, you never want to be on that website. It's a very bad thing to end up on that website. So obviously the bank needs to be sure that this stuff is secured, and you as a developer have to think about how you're securing this data, and are you taking all the measures that are necessary. I mean, managing all this interconnected data, as I said, I mean, keeping track of who you've shared what with when is obviously a huge challenge. But at the end of the day, and now comes to my little story, understanding what the customer actually wants, what data you want to provide in these APIs. And here, I mean, as I said, we have over 400 APIs, I mean, 7,000 if you want to use the number that the engineering team gave me, but we had one customer, and customers decide which ones they want to activate, which business type should be replicated to the cache database. And we had a case with a massive database, a huge, I mean, synthetic data, anonymized, but we're talking like hundreds of thousands of customers and over 15 years of transaction history. And we just activated everything, synchronized everything. So I hit go, I went, did some stuff. I came back 3 hours later, it had stopped. It's like, okay, well, this is odd. And then I noticed I'd run out of, storage on my Kafka PVC. So then, okay, I increased the storage a little bit, ran it again after 6 hours, the same, still missing millions of entities in my database. And I mean, then we started running all these sizing scripts to figure out what could be the possible problem. And we noticed that for a lot of these business types, there was over, I mean, sometimes several terabytes of data that would have been replicated, even if we didn't need it, just by hitting, select all and hit go, send it. It was a huge mess. So we had to go through that to figure out what the problem was. And actually the biggest the biggest object in my database was a currency asset. It was the US dollar, which was 10 megabytes large. So I called the API to return information about this asset, the US dollar. I waited 76 seconds, and the response was a 10 megabyte JSON. And obviously, I mean, this is completely unusable. If you're thinking you're building a third-party application, you want to wait. First, you have to wait for that to be generated, and then you have to somehow parse this 10 megabyte JSON, even if you just want 1 or 2 fields. Again, you can make your own shapes and with this GraphQL language to specify exactly what you want, but that was basically what was stored on the database. And we saw a lot of these cases. So, I mean, the problem there was there were classifications set on this asset, and there was an end-of-day job that was updating it every day, but the value had never changed. So the application was working as intended and designed. It was, I mean, obviously banking, highly secure, maximal reproducibility, and audit trail. It was doing exactly what it was intended to do, but this data was completely useless to us, useless to any application that would want to consume this. I mean, another fun object was actually the account of a person, so your money account, where interest was also computed daily. So every day you had like a timestamp and then how much interest you got paid that day. I mean, it doesn't sound like a lot, but when you have, you know, several 100,000 accounts that have transaction histories or accounts that are older than 15 years, I mean, that was also several 100 gigabytes of just garbage, stuff that we really don't need. I mean, I don't think anyone is going to want to analyze the interest rate over the last 15 years. You can just calculate it yourself. You don't actually need that in your database. So it was stuff like that. Yeah, I mean, we basically had to touch most of them, but this was something that we didn't catch when we were working on our synthetic data, on our model bank database. But once we, you know, took it into the field, took it into the wild, these were revelations that were very fast we then found. But yeah, anyway, which brings me to my final slide. You know, we have a sandbox. Avalok 1 is basically something that we are providing to developers, to fintechs, to basically start working with us or want to like give those APIs a try to integrate them with your applications. We're also currently reworking the entire strategy for this for the next 6 years and plus. Because right now, I mean, it's a process. For me, it takes too long to get new interested parties involved, and this is definitely something we're working with. If you concrete have an idea, or if you want, to help us define how, you know, a proper development experience looks like for a sandbox environment like this, you know, we're super happy to talk to you. We can cut through some of the red tape and get you started real quick, and obviously we'll listen to your feedback and, you know, anything that would help this collaboration, because this is something, it was, as I said, it's overcomplicated now. We want to make it better, and with your help, you know, we could really achieve something great here, and you can obviously get access to this wealth of data and information in the process. So yeah, we're recruiting, avalok.com/careers. Actually, my team, I'm the only person in my team. I'm in the new products and services delivery team, I think it's called now. Yeah, if you're looking for a job where you're not doing the same thing over and over again, because obviously my team, we handle all the latest stuff, you know, straight out of our engineering department and then deployed at the customer for the very first time. If you're interested in those kinds of challenges, you know, look me up on Slack or LinkedIn, and you know, let's get connected and stay excited about the future of wealth management. Thank you very much. Thanks for your time. Bye.
All right, let's get started. So Thomas and me will give a presentation today about Merantix and how to bring AI into production fast. So I'll give a quick overview of Merantix first, and then Thomas will go into the technical woods in the second part. Feel free to also ask questions, I guess, also in between. I think we're a relatively sizable or small sizable audience, so if there's anything that is not clear, let us know. Yeah, let me start. So Merantix was founded 5 years ago in Berlin. We are a venture studio building AI-first companies. So the way it works is basically we work with founders who ideate with us, test and validate ideas, and when we have enough conviction, we basically spin it out in its own company. And so Merantix really supports in all aspects. So not only it provides capital, right now we invest up to around 3 million euros per company, but it also provides access to the industry, and it also actually co-locates all the companies. So there's a lot of exchange also happening between our companies. And so far, we've been building 7 companies. We have 3 founders ideating at the moment. We have 10 more companies we want to build in the next 2 to 3 years. So quite an ambitious plan. And we also recently set up a fund of 30 million euros that basically allows us to build those companies. And that was also backed by some big investors like SoftBank, which really helps us also now to further scale those companies. Recently, actually in April, we also opened an AI campus in Berlin. So it's a physical space where currently around 500 people work on AI applications. So it's a place where our own companies are, but where we also co-locate other companies. So we have, for example, a few Fortune 500 companies there. We have a collaboration with all local universities that put all their spin-offs that are data and AI related on the campus. And also quite a few startups. And the idea basically is that you can collaborate there, do business together, also exchange knowledge, and also have like a great working environment. I think we would have never done this if we would have known how much work this is to set up such a physical and not digital environment or product, and that Corona came, but we actually signed the lease before Corona. But funnily, it's still like quite busy now. So it's 90% occupied because the way the campus is built is also quite post-COVID friendly in a sense that it's a very nice place if you want to work from there for a few days, and if you want collaboration, but also for a lot of focus work, you can work from home. And there's also a lot of companies involved. There's a lot of research collaborations. This logo list is actually 2 months old, so that's probably another 20 logos by now. So it's a quite cool place. So I want to invite you all, if you're ever in Berlin, feel free to drop by. It's also, we live at like an open house. So if you are in Berlin for, a week and need a place to work from, you can always come by and just hang out there. And that's because that's also super valuable for the companies there to have that exchange. So yeah, quickly about our companies. So our first one was Vara. It's a breast cancer imaging company which has trained in algorithms on millions of cancer images to basically better diagnose breast cancer. That's a medical product. Actually, every week we find quite a few cancers that doctors would have missed. So it's in production. It's running all over Europe. We are right now expanding to Latin America, where we also set up our own screening programs. We are right now doing also FDA approval. So we're also going into the US market. And I think it's a very neat application of AI that kind of brings together a lot of different parts, like the algorithmic part, but also the medical part, the regulatory part, and also building a product that doctors actually want to use. And yeah, the algorithms perform very well. There was a recent paper, like last year, I guess, from DeepMind around breast cancer imaging, and we quite largely outperformed their performance. So there's also a lot of very interesting machine learning happening there under the hood. Second company is HackZurich. It's a data management company, basically working mostly with large automotive companies, helping them to, and AV startups or startups in the autonomous mobility space, helping them to manage large amounts of sensor data. Because you can imagine when you have a bunch of cars collecting sensor data, you end up having petabytes of vision data and LiDAR data, and basically HackZurich builds a data catalog on top that helps you to search that data, to filter that data, to figure out what you want to keep and what you want to throw away. Third company we started last summer is Cambrium. It's a synthetic biology company. There we basically use machine learning to optimize protein material so that they have the right material properties. So on the one hand, there's a kind of machine learning part, which is around basically you have like DNA sequences and you try to predict their material properties and then optimize them. And the other part is also running the experiments. So we have set up a lab in Berlin where we run those experiments, collect the data, and thereby optimize the proteins. Initially, we focus on collagen, which is used a lot in cosmetics, but there are a few more materials we are working on right now. Fourth one is Causa. Causa is a company in the business intelligence space. So the hypothesis there is that a lot of companies now start to have more or less clean data, or like more clean data than maybe like 5 years ago, especially digital first companies. And so you actually can now make the whole organization much more data driven, because everybody has some KPIs they care about across the entire organization. But the truth is, like, when you want to understand what's driving the KPI or what's kind of interesting in that KPI, it's still like you still need to do a bit of data science, or you still go to your business intelligence team, and we want to basically automate that, because our deep belief is that whatever a data scientist does there, you can be automated. Because if I give any of you a data set and I tell you, hey, I care about this KPI, tell me what is driving it, and you look at the other columns or other tables, you will always do the same things. You will look at trends over time, you look at subsets, you look at outliers, and ideally also causality, which is then kind of the next step. And so we want to automate that, which is a very ill-posed and hard problem, but I think very valuable when you later can say, hey, I care about this KPI, tell me 5 reasons or 5 things which are interesting about that. And that way you can make your whole organization data-driven just by plugging this Causa on top of your data warehouse. So they right now focus a lot on gaming and e-commerce, but then want to later broaden the horizon there. And then last couple of months, we started 2 new company, Brink, which is a regulatory tracking company. Basically, there's a lot of new regulations coming out, also for good, like around ESG, supply chain laws, and these kind of things. And it's actually quite hard to have an overview as a company, what's happening out there, and what is affecting me as a company, and what might affect me as a company. And so what Brink tries to do is basically crawl all these regulatory sources and give you a very clean dashboard that you can just say, look, hey, I'm in the hydrogen space in these countries, tell me what is affecting me. So that you also, as a manager, get peace of mind, a bit like a cybersecurity product, in this case around regulatory. So that's a company we just recently launched, work with quite large companies there together. And then we're launching another biotech company. It's very researchy. Basically, the hypothesis is that the whole food and nutraceutical space is getting much more data-driven also, because people actually care about what they eat and what they drink, or take nutraceuticals because they want to enhance themselves. And so that whole space, there's a lot you can do with that data, also around natural compounds, and you can actually learn a lot from pharma there, how they work in drug discovery, and we basically want to apply that to the food and nutraceutical space. First step there is to build our own data set, so we actually plan to build the largest natural compound data set in the next 12 months globally, which is very interesting because the data is actually spread around research labs, partially also in like ancient Chinese literature, so very, very all over the place and very different formats, and so we try to bring this all together, and then build algorithms on top that basically help us to predict how these compounds interact with the targets. So a kind of more computational approach, and initially we built this as a platform, so we actually collaborate with quite a few CBD, superfood companies and the likes, but ultimately you could even imagine to vertically integrate that and build your own products there. And then lastly, with Merantix Labs, Thomas will talk more about there. He's the VP of engineering of Merantix Labs, but that's the last and also very strategic company of Merantix. And so just wanted to, before I hand over, just wanted to give you an overview. I mean, we are hiring in all these companies. We're building new companies, so if you have any question, I'm obviously going to be around here until tomorrow, until the end of the event, so feel free to just reach out either in person here or write me on LinkedIn or an email. It's rasmus@merantix.com. If you have any questions, if you want to collaborate, if you want to join, there's a lot of exciting stuff and in very different verticals. And I think it's also, even if you're working one of the verticals, there is a lot of, I guess, also interaction with the other ventures. So I think you will see quite a broad spectrum of ML applications in production. Thank you very much. And with that, over to Thomas.
Thank you for the kind introduction. Nice to be here. So I think Rasmus could already convey you that we already did our journey to bring AI models into production, like in various different fields and with very different models. And why does that matter, especially for Merantix Labs? Because within the Merantix ecosystem, Merantix Labs is a solution provider. So we build bespoke solutions for clients in different industries. So what basically one of our main assets is we can do this in a good and structured way and help our clients for very diverse use cases. And optimizing this, of course, is one of our goals. And today I want to share a bit what we do there and go from a high-level view until we reach the terminal and show how we do that. So first of all, let's start with a fun example because this just happened like 3 weeks ago. Usually we have clients which have like use cases in various domains. You don't really see what we are doing there, but this is a recent example where you can see some results of Merantix Labs, what we basically do if the video starts.
Herr Böhmermann, Sie haben mich angerufen und gesagt, ich möchte Sie interviewen. Warum?
Ich habe Sie angerufen, weil Sie eine wirklich wichtige Aufgabe haben und eine.
So this was just a clip from a German TV show where we provided some deepfakes, which was a really fun project, but like the quality that you have to deliver in the end is basically people can not recognize that it's actually a made-up footage. But if you go, for example, to other projects that we do, we have a lot of ML challenges in the wild, and if you actually don't tackle them, you can produce a lot of harm. And some examples here are, for example, class imbalance. So one class is that you want to predict is very dominant. Just think, for example, here in this example, you have a lot of normal cells in this histopathologic images, but just a few ones are cancerous, and that are the ones that you're interested, but they are very rare. And ML models tend to just predict more like, or tend to move to the average, and tackling this class imbalance is very important to make it work in production. Also, for example, hard samples, also a very huge problem. Here you see this mitotic cells, so cells that are dividing. They are very important to detect how fast a cancer progresses. But you also have these non-mitotic cells, for example, apoptotic cells that are like cells that died. They look very similar, but they are not important for this task. But you can confuse these two types of cells easily, and tackling these very hard samples in comparison to all the easy cases, which are the normal cells, is a tough task that you have to tackle. And also domain shift, for example. You can see the top row, and it's a little bit brighter compared to the bottom row. And it's just from two different scanners. So you already have a shift how the images look like just by using a different device. And this can also confuse the algorithm. So you have to tackle that. So what we do is we basically take all these the methods for tackling these real-world challenges and put them into platforms that we use. And in these platforms, we model basically solutions for these problems as heuristics. So everything which can be automated for solving these challenges basically get automatically generated in the pipeline, and everything else gets handcrafted. So in optimal case, you have a use case where we already solved everything. Then you're basically at AutoML. You put it in, the whole pipeline gets generated, you have a nice model. If it's something new, custom, you need a lot of domain knowledge, then more and more parts have to be handcrafted. And the key to make this work is basically having a pipeline which is highly modularizable and also customizable, so you can hack it to the ground. And there are components in there also to remove some manual work from the engineers, like hyperparameter tuning or getting more training data, like with active learning techniques. So how does this look like in practice? So first of all, you bootstrap a place to upload the data, for example, for a client. You make all your customizations of your model and basically build the model, train it, then package it in an API, deploy it, and then monitor it in production, and then replace it if you have basically a better model or something is off. What is very important for us is that we can do this for every client, because we have to have separate environments in different clouds where we can still inject our custom assets. And this is very challenging for us, so we came up with some solution that I'll present next. But this whole thing is just a very small piece of the whole workflow, the ML part, because you have to validate the model, you have to deploy it, you have to think of all the configurations, traceability, whatever. There are lots of topics that you have to cover. And you can still put all that into like a unified workflow where you can automate as much as possible by either guided tooling or some which is basically some semi-automatic workflow or even some automatic tooling like a continuous deployment server. So let's talk about the first part. So if we think of it of an ML ops view, you first have like your experimentation environment, you have your development environment, and then you have your environment for operation. And of course, you want to have all of that pretty close, so you don't have like a gap where you have to adapt between these environments. And the best case would be the people that build these ML services can operate them themselves. That is like the holy grail, and we try to do that. So there is like an ML ops team who builds the tooling for all the other engineers to bootstrap different kinds of environments for different clouds in an automated fashion. So here is an example environment. Like in Google Cloud, you need different components, code with version control, continuous integration server, some hosted documentation, some secret management, artifact stores, yada, 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 all these components. And then we usually deploy a Kubernetes cluster or a managed one, because there we can deploy cloud agnostic our in-house components. You need experiment tracking and then also a deployment infrastructure and so on. Lots of stuff. And usually if you look at data scientists, they lack the skills of setting all these things up and operating them. But we enable them by using some more smart tooling. And what is also an advantage of doing that is all these technologies, they come and go, and you have to constantly replace these technologies in different projects at scale. At the same time, have to think about things like, oh, do we do this in-house? Do we do this by just buying something in and roll all these stuff out basically to all your ML teams. At least for us, since we do bespoke solutions, we have to like bring it to all our teams. At the same time, we don't want to like be dependent on one vendor and so on. So many things to consider, and you don't want to give that burden to each individual team with data scientists, but at the same time, each of the environment is different. So how do you solve that? So what we did, we introduced the dev tool, what we call it. So this is your Swiss Army knife for ML projects. So what does it do? So I think biggest component that is important here that I will show later are the project generators. So we kind of took a concept from Ruby for generating code and brought that into the ML world. And what does it do? It helps, first of all, setting up the project, and for new joiners, helps getting into a project because the infrastructure looks different, but still alike. And you can preserve learnings there by moving all the learnings into these generators and rolling them out at the whole company. Moreover, what is in there is infrastructure as code, which is also rolled out using these generators. And maintained usually by the MLOps team. And also for other things, there's tooling for best practices, for example, for checking your code, for deploying models, for checking open source compliance, all these stuff where there are like semi-automatic steps involved where you can guide the user, which are usually power users, but you can basically guide them through the process with everything which is automated, just running as a script, and everything else more like an interactive UI. So how does that work? So let me just walk you through an example. So let's start a new project by generating, first of all, a project state. So, yes, you can see it. So basically, now we generated a project state, which is just a file which tracks all the state of which services you actually use in your infrastructure of a project. You can version control this and then build on top of this state. So now let's start with a standard project. So we have different kinds of projects. We are pretty strong in research, so we have like templates for research projects, for client projects, for just Python packages that we use internally. And then you can generate this standard structure based on your needs. So then it starts in this, asking you questions in this semi-automatic process. So what is the GitHub repo that you want to have? What is the cloud provider that you want to use, the license, all these kind of stuff. And then it renders all these files in like a hierarchy of generators. So it's not like cookie cutter, you have one template, get one output, but it's more adaptively modifying the template based on basically what you need for your project. So you get, for example, Terraform for infrastructure as code to spin up your project. And all these things are then like what you basically deployed in your project is then in this state file, which is just a YAML. You get a custom Docker container for your project. This is very useful. You get some Kubernetes infrastructure and, for example, MLflow tracking server for experiment tracking. This is just basic things that we usually deploy in our client projects. In Google, what we just selected, you get a managed Kubernetes cluster, roles management, everything generated just with this one command. And now you want all this infrastructure, just run a Terraform apply on it, wait a few minutes, and you have all these things that I showed before on the slide, like everything from CI, deployment of docs, deployment of your model, experiment tracking, all these things. Just a nice standard setup to do an ML project. And you can, as I said, for different use cases, there are different generators. But if you want to have one specific service, which is maybe not default, you can also add or remove them by running the generators or the corresponding delete generator. So, for example, I have a tool, computer vision. I need a labeling tool, want to provide it to a client. So we want to have CVET. CVET needs like a web server, you need like a balance loader, you need accounts, storage for upload, you have to register a domain, all these kind of things have to put that all together, make it secure. Maybe as a data scientist, you don't want to do that. But you can just run mxg cvet, the command. It detects, oh, I have a Google project, so let's run the Google cvet generator. Generates all that stuff for Terraform, for the Docker containers and so on. Puts up a proxy for authentication, integrates like with the other services in your project, and integrates them into the endpoint that belongs to the domain that is also registered with CVET. And then you do Terraform apply. Then we use, then everything gets spin up, and then we use dev space, which is pretty nice to deploy experimental environments in Kubernetes clusters. Here you get the introduction, run these two commands, you do that, and then you get cvet running at cvet. The project name URLs that is registered and can forward that to your client with some user guide how to use it. And that's basically it. And every data scientist can use that, and all this tooling is then provided by the MLOps team and basically centralize there. And if they figure out a nicer way how to deploy stuff, they can just put that into the generator. They get a new version in their project of the generators. Everything gets like regenerated and rolled out at scale. Because if you don't use that thing, it doesn't get like replaced. If you use that service like CVET, it gets replaced, and you just configure that in your project state. And this really helped us like scale ML projects and all the deployment of these complex services in our very diverse projects. So now let's quickly talk about operation, because this was mainly about how to like set up an experiment environment, like labeling. This is still like pre-production usually. So what we do there, we deploy usually an Istio service mesh with some seldom core environment in there, where you can run some microservices, do like canary deployments, all that nice things that you want, authentication, and have like an inference graph over your ML components. And then we provide some core monitoring that is usually deployed with your model, like some dashboards, input data can be logged if you want, or predictions, and some visualizations here. And then we usually add some customized components based on the use case. So what people are interested in are explainability methods, like SHAP for model, some outlier detection. Is the input that you put into the model very off, or is it even an attack? So we also do lots of research on how to detect adversarials in your input, and then have it here as a service, optional if the data scientists think this is useful or requested by the client. And also drift detection, also getting more and more important, because you deploy your model once, but often it doesn't last for long. Like the data shifts, and then you have to like come up with a new model because the input data doesn't fit the model anymore. But you also have to detect this, and it's nice to have a service for that. And also one thing which gets more and more popularity is asynchronous feedback. So often you have use cases where you deploy a model, and then people use basically the predictions of your model for their use cases, but after a while you get like ground truth back, for which can be anything. For example, you predict if somebody gets cancer or not. At some point you will know if that really was the outcome or not, and then you can provide this feedback back to the system and have an overview if the model is correct or not, which is a pretty simple concept, but very nice to evaluate your model with like real-world outcomes. And what we usually do as a workflow, most of our models are in PyTorch because we are very focused on deep learning methods. We train our model, package it, validate it in our pipeline, which is still like in the experimentation stage. Then move it to production. First of all, shadow it to test it out, maybe some canaries with some few users, and then roll it out to the whole user base, basically. And this is basically a shift in the standard use case from an ML flow environment where we have like the experimentation tracking to a seldom environment where you have the inference graph in your basically Istio service mesh. And with that, I just want to like sum up everything. So there are lots of challenges in production, especially if you have like more serious use cases than just making some deep fakes for a comedian. What really helps us to tackle these challenges is semi-AutoML by building heuristics to detect these challenges and then providing solutions to the data scientist. And infrastructure is a key ingredient to scale this, because the people that build these ML models are usually not experts in infrastructure. And our solution to that is the dev tool with best practices as code and infrastructure as code. And what is often also forgotten, which is very important, that it's not just about deploying a model, but then also keeping track of it if it's out there and running and having like impact in the wild. And you have to also loop that back and do something if it doesn't do what you want. So this was it from my side. So if that was interesting for you, we are hiring, especially if you want to build like the next gen ML stack. You're welcome. Just drop me a mail, and maybe you have some questions. I also take questions from the internet if there are any.
We can also, I guess, do the questions like offline now. Yeah.
Yeah, let's do it.
Yeah, so Tom, you are also around until tomorrow, or definitely this afternoon, so if there are more questions, just come up. Cool.
Let's do that. Thanks, everyone. Bye.